En, to. En, to. Bright lights, that means go time. All right, before I start, just want to let you know, the people from the video setup told me that they have a fancy new camera that follows me around using AI, so I'm going to be running around. I want to test that thing. Kidding aside, good morning, everyone. Thank you for joining me here on the third day of NDC already. It's been a good one for me. I saw a lot of interesting things. And this one might be different from what you saw. A lot of the different talks that you've seen are how should you do this? What's the best way to do this? What's the best practice to use this specific thing? This presentation is a war story. This is an actual project that we did. Me as an architect with an entire team, I will dive into more details about the team setup later, but this is an actual project with a customer making his own decisions that we had to work around because customers, right? Who here is a consultant? Who works with customers? Bunch of people? Okay. So hopefully, and in other places where I've done this particular presentation, the problems we encountered really resonated with other consultants, with other people who have to deal with clients. So hopefully that's the case here as well, so we can share our pain. That's it. Hello, everyone. My name is Nico. I'm a senior application architect at a consultancy agency in Belgium called Initum. I've been a Microsoft MVP since 2014. Back home, I run some stuff, user group. I also help run a conference called Tekorama. And I do a bunch of other stuff. If you want to follow me around, I'm mostly active on Blue Sky, a little bit on LinkedIn, but that's the only social medias where you can reach me these days. So if you're on Blue Sky, give me a follow. Much appreciated. If you have any questions after this talk, you can find me running around here somewhere. If you think of questions in the coming days, reach out. I'll be happy to respond. Okay, setting some expectations about this talk. I'm going to show you how we used Aspire and Dapper in this particular project. I'm going to be ranting on my customer because they made stupid decisions. So that's a big part of this talk. I will also explain why we made certain decisions and how those decisions do not really fit into the demos that you've seen of Aspire and maybe Dapper. But that's kind of how it goes. Now, unfortunately, I can't really talk about the actual project. That is to say, I cannot name the customer. I cannot name the project. I can say that it was government, which should tell you a lot. But that's about it. Now, what did I do? I created some replica codes that kind of mimics the project in places that are important. I took some screenshots of code. I took some screenshots of the Aspire dashboard, blacked out the things that they probably don't want you to see. But that should be sufficient to give you a good idea on what we did. Okay, so this project got started February last year. I got pulled in January as one of two architects. And just to give you an idea, when the team was at its biggest, there were 2 architects, there were 5 developers, 4 people doing analysis, 3 people doing QA, 2 PMs, Scrum Master, and I think 2 or 3 proxy POs. Really, really big team. This project was 3 million in 1 year, euros. Now, when we got started, customer said, we haven't decided on where we want to host this thing. This will either be the very first cloud project that we do, or it will be hosted on our on-prem Kubernetes cluster, which we are currently setting up. But if it would be cloud, which we were really pushing towards to, then the cloud environment will be set up by a different company. They will create a cloud center of excellence. You will have to discuss with them. They will give you your resources. You will not be in control of the cloud environment, which kind of makes sense. And because of this, they told us, because we haven't decided yet on where to host, you need to use Terraform for infrastructure as code. Who has ever used Terraform? Ooh, a lot of people. I'm so sorry. The reason they pushed Terraform to us was, and I quote this literally, with Terraform, you can start on Kubernetes, and if you do decide to go Azure, you can just take it and deploy to Azure without any change. That's not how Terraform works. But we couldn't convince them otherwise, so we were stuck on Terraform. And this is important because Aspire comes with a full deployment story as well, which does not support Terraform. So there was that. The technology stack was ASP.NET Core API in the backend. It was Blazor server in the front end with SQL Server databases. Why? Because they were already doing quite a lot of internal development. This was the tech stack that they had. This was the one that they used. They were happy with it. We had nothing against it. It's a decent stack. It's a good stack. So that's what we went with. Then came the authentication authorization story. That was Identity Server 3 on-prem. That was set up. We had to use that. Fully configured with a bunch of users, a bunch of roles. This was what we had to use. Now, if you don't know Identity Server, the people from Duende are right on the other side of this curtain. They are not on version 3 anymore. Version 3 is out of support for a long time. But that was what they had. No upgrade was possible. We had to use this. OK, fine. Can we get access to a test environment of Identity Server? No. OK. But then how would we be able to test our login system, our authorization, our authentication? Oh, we will give you a local STS project that you can include in your solution that you can reference. It's based on Duende Identity Server 4. OK? But do at least the roles and the users match? Not really, but it should be close enough. OK, fine. Oh, by the way, they told us, we have a library of Blazor components that you need to use so that every application that we build in Blazor has the same look and feel. Sounds reasonable. That's been created by a different third party, and we were the first application to use that, meaning we got to discover all the bugs and report those back to the team that would put them on the backlog somewhere way down. So by now, we need to deal with the actual customer itself. We need to deal with the CCOE, Cloud Center of Excellence. We need to deal with the component builders. And then we had our own team, 4 parties building this thing. Eventually, they went for cloud. So spoiler alert, it was cloud. So in order to tackle that, we made a decision to go with Dapper. Because Dapper, and I will go into more detail on what Dapper is. Oh, maybe first, who has used Dapper before? Okay, some people. Aspire? Okay, cool. It's not a majority, so I will do a quick overview of what both Dapper and Aspire are before I go into how we used it, just to make sure we're all on the same level. So Dapper is basically an abstraction layer on top of a bunch of stuff. I have a nice diagram coming up. But we use that to put an abstraction on top of things like storage or service discovery. In order to, if we would deploy to cloud, it would work. If we would deploy to Kubernetes, it would work as well. So that was a nice way to already get started. With Aspire, it would enable stuff like a faster inner development loop. Things would start up way faster because you don't have to configure your multiple startup projects and stuff. Working with containers is easier, just hooking all the resources up together. That was the excuse that we used against our customer. But having 2 architects that are really into tech, we just wanted to use this. We heard about it, it sounded fun, we need an excuse to use this, and the customer went along. In the end, it turned out really good. It really, really helped us. I'm a big fan. The thing is, at the time, Aspire was on preview 2. So really, really early days, which also meant that you needed to use Visual Studio Preview in order to use Aspire. So once we convinced our customer about Aspire, we told them, well, there's this one small extra thing. We'll need to use Visual Studio beta versions. Oh yeah, that's fine, just do it. So that's what we did. And then we kept upgrading with every preview release that came out. And then we went to GA, and it's been really, really good. OK, so quick timeline of the project. January, everything got started. We started doing meetings. Decisions were made. February, the team started pulling in developers. We started doing actual development work with Aspire Preview 2. Once we got started, a week later, they released Preview 3. It took us a full day to upgrade. There was not a lot of code in there yet, but these were preview versions, so a lot of breaking changes every single time. So it took us a full day to upgrade. Didn't really matter. By the way, this was a fixed scope, fixed budget project, so it didn't really matter to the customer how long an upgrade took. We needed to make the deadline, and it was our responsibility. In March, Preview 4 got released. That was kind of an easy upgrade. But then going to Preview 5 in April, that was a big one, because they did a lot of renaming and refactoring in Aspire at the time. I think they went from integrations to components, or the other way. I don't remember, but there was a big change there. And that upgrade was a really, really big one. I think that took us 2 or 3 days to do. And us, meaning one dev was assigned to upgrade Aspire to the new version. I took him, so 2-3 man days. In the same month, Preview 6 arrived, quite an easy upgrade. In May, there was a final upgrade, and then they went GA at build at the time. Going from Preview 7 to GA was again a difficult one. But we took the time, and that also meant we could go back to Visual Studio Stable. So we were again in a stable environment. Then in June, we still had no Azure resources at that time. The decision on cloud had been made. We knew we were going to Azure. And then our customer said, we are working on creating the Cloud Center of Excellence. It's being set up, it's coming, don't worry. Yeah, but when will we have our landing zones? Oh, you'll have them by October. Deadline of the project was November. So that will not work because we have acceptance coming up. And okay, you know what we'll do? We'll hire another partner, another external company that will set up temporary landing zones for you. So you can at least start building your Terraform scripts, you can start deploying, you can start testing. Good. That happened. In June, we got those. We started, I did a Terraform script. That's why I know what it's like. I did the scripts, everything got deployed, everything was running, everything got smooth. Then in August, they told us, we have good news. The real landing zones are already here. Oh, okay. They look nothing like the temporary ones. Completely different. So I had to rework all the scripts in order to deploy into the new landing zones. That took a lot of time. Eventually that worked. In September, we got an email saying, those final landing zones were not so final. We're going to replace them with, again, new landing zones. Because we came into new insights. Okay. By November, Aspire 9 got released. I got moved on to the next project. The team is still working on it. I think the first version is currently in production. And they have upgraded to Aspire 9, and they keep having really good experiences with it. So that's a bit of timeline. Now let's talk architecture. The project is kind of distributed, but it's not a microservices project in any way. It's two separate front-end, back-end applications that talk to each other. That's it. One tool is internal, one tool is external, customer-facing. So our customer has internal people configuring everything through a web UI, which is one of the two web front ends here on the diagram. The other one is facing their customers, and they get to interact with the system that way. So two front ends, both Blazor, two web APIs, they both connect to the same database. Why? Because our customer wanted it that way, because two databases were too expensive. Fine. We didn't really care about that. There's two different schemas in there, one for each project. The internal facing app is used by 4 people a couple of times a year. So it was not that bad to have one database for both. Then there are a bunch of external APIs, APIs that are being hosted on-prem of our customer that we needed to contact in order to get certain information. Talking about protocols, we communicate with our own APIs through HTTP. The external APIs, and one of them is the Identity Server 3, by the way. The external APIs are being done through HTTP, gRPC, combination of those. All being built by internal teams, but that communication went quite well. So hosting, this part is on-prem. That part runs in Azure. That part is Azure Container Apps. One Azure Container Apps environment, 4 containers. And then the database was an Azure SQL database. That was the setup. And because we are using Dapper, we have sidecars. Now, the sidecar pattern is a container pattern where Dapper really relies on to do its work. So a quick sidestep into what Dapper is. This is a diagram coming from their website. So Dapper is technology agnostic. It's an open source framework. Stands for Distributed Application Runtime. It's written in Go, but it has SDKs for all these languages that you see on the top here. Microsoft is involved. They don't own it. It's a lot of people together that own the thing. And it has a bunch of building blocks. Like you can do workflows, you can do PubSub. There's an actors framework in there. There's secret management. Service invocation is what we used heavily. State management we used as well. There we go. Those are the 2 building blocks that we used. There's way more in there. Now, what do I mean with these building blocks? These are basically abstractions. You have one SDK that you use, the Dapper SDK. It works in a very similar way across all those technologies, and it abstracts away the underlying implementation. For example, let's take the secrets building block. You just define Dapper secrets. It's all YAML. And in that YAML file, you define that in this environment, I want to go to Azure Key Vault. And when you run it, the SDK will load in the configuration file, and you will actually go to the Key Vault that you specified. You want to do this on AWS. There's a different thing, I forgot the name, but it does the same thing basically. And you don't have to change your Dapper code because you just change a config, and it will go to that one. That's what it does. It's an abstraction layer. Now, I told you we are using Azure Container Apps, and Azure Container Apps has native support for Dapper. It's right there. This is a screenshot of the Azure portal. It has a Dapper entry there. It's natively supported. You just specify that you enable Dapper. You specify an app ID, protocol that you want to use, and that's basically it. You can do some extra configuration there, and that just works. Now, I spoke to you about the sidecar pattern, and the sidecar pattern is basically you know a motorcycle that has a sidecar attached to it? The sidecar cannot do anything on its own, it needs to be attached to the motorcycle. That's basically it. You have your container running, and you have an extra container that's connected to it. And all it does is it enables new features to that container. It cannot do anything on its own. It needs the container that it's attached to. That's what the sidecar pattern is. And this is what Dapper is relying on heavily. Because Dapper lives in that sidecar. All the abstractions that you build, all the configuration runs in that sidecar. For example, if you want to make an API call and you use Dapper Service Discovery, the only thing you do in your SDK is you call invoke method async. You pass in the application ID, which was here. You see app ID in the portal. You pass in that ID. You pass in the method that you want to call, your REST method. And what will happen is your front end will, using the SDK, will pass that command into the sidecar. The sidecar will look at it, will go, I know this app ID. I know where that lives. I know where the sidecar lives of that API. It passes that command along to the sidecar of the backend. That sidecar forms the actual HTTP request, the actual REST call, forwards that to the API, and the result comes back. So yes, it's a bunch of extra hops. You go front end, sidecar, 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 backend. But you get a lot of flexibility in return. Pure from a reasoning standpoint, I would say, yes, you take a performance hit. But if I run the metrics, sometimes doing the call directly is even slower. I can't really put my finger on it. Reason dictates that you take a performance hit because you're doing extra hops. Now, the hops between sidecars are by default done over gRPC. So they are way faster than simple HTTP calls. There's that. Just another really quick Dapper thing. This demonstrates the different building blocks and examples of implementation. Like, again, going with secrets, you have the AWS Secrets Manager, there's the one. There's the Azure Key Vault. There's a Google Cloud Secret Manager, and so on. For PubSub, you can do Azure Service Bus, you can do Redis, you can do RabbitMQ. There's many possibilities. And again, you don't need to change your code if you want to change implementation. You just adjust the config file, that's it. Also makes it quite easy to differentiate between local development and deployed. For example, we used the state store to upload files. Locally, it just deploys to the file system. Once deployed, it goes to Azure file storage, blob storage. So you can differentiate between environments there quite easily. Now, enough PowerPoint for a while. Let me quickly show you what this looked like. So I'm just going to create a new project, create a new web API. I promise it's quite a quick demo, just to give you an idea what Dapper looks like. Let's create it. All right, and I'm just going to add a front-end project to it. Front-end being Blazor. There we go. Now, normally, everything that you do with Dapper, you would do outside of Visual Studio. You would create the YAML files manually and so on. But there is a Visual Studio extension for Dapper, an official one, that gives you things like right-click, add Dapper run file. If you click this, it will inspect your solution. It will create a sort of Dapper project. This is not an actual project, it's a virtual thing with the Dapper YAML file. And you can set this as a startup project. Let's increase this a bit. Is that big enough? Yep. All right. But this one can go. Okay, so what this did is it inspected my solution. And now I have 2 entries in my Dapper run file, one for every project in there. I have 3 projects in there. One is the Blazor server with the Blazor WebAssembly, which is the default Blazor template these days. So there were 3 entries in there. I just removed the one that's only WebAssembly because that one gets started from the ASP.NET host. So remove that. So by default, it has an app directory path. It generates an app ID based on the project name. It assigns a port, gives a few commands, and that's it. So normally, you would do from the command line dapper run -f dapper.yaml. This would inspect your Dapper file. It will boot up everything, every application that's defined in there. It will load in extra configuration files if you have them. Everything will start up. You get ports here, and everything starts working. But you're still dealing with YAML files. Even though the extension helps, you're still dealing with YAML. So quickly going back here. Okay, so why did we do that? Again, small repetition. Why did we go with Dapper? For the abstraction, purely that. Because we were waiting on hosting decisions, we needed to find a way to get started. And Dapper got us there. It bought us some time. Didn't do anything else than that. If this wasn't the case, would we have gone with Dapper? Probably not. I do see some advantages in using it. I don't quite see it as a necessity at the time. But you never know. All right, second part of the project was Aspire. Aspire is a framework, a stack, an opinionated thing coming out of Microsoft that provides a C# way of defining your system. It's not infrastructure as code. is just a way to define your distributed system, to hook everything up. You know what? I'll just go show you, which is easier than explaining things over a slide. So, file, new, projects. Aspire 9.3 just got released. So there's a Aspire starter app template. In here, you have some options. You can select the version now. This is new. You can enable Redis automatically, have some XUnit in there. Depending on what you select, you do need to have Docker Desktop or some container runtime installed. Visual Studio integrates really well with Docker Desktop, so that's what I'm running now. All right, let's see. For those of you who have never seen Aspire before, this is a Aspire project. Out of the box, you get a backend, API service, you get a front end, which is Blazor again, you get a test project, which in this case was XUnit. You get service defaults and the app host. Now, what is this? Service defaults is a bunch of extension methods that add stuff like health checks, open telemetry, service discovery is being set up here, resiliency. You can set up whatever you want here. If you want to do application insights, you can just add it here. Azure monitoring, for example, you just paste a connection string and it's good to go. And these extension methods, if you go look in the program CS of the backend, for example, you see them being called here. Meaning that all the projects in this solution have the same default service defaults. The same logging that they go to, the same cache, the same whatever. It's all defined in the service defaults, which is a neat way, but it's nothing special. It's just extension methods. The real magic of Aspire is in the app host. This is the apphost.cs. It relies on the builder pattern that got introduced with ASP.NET Core, but they have a distributed application builder. Yep. And you basically define your projects here. So the Redis cache is being defined here. It's just a variable that you have done. Then there's the API service, and there's the backend. There is some source generation going on here. For every project that gets referenced by the app host, it will generate, where's my 12? It will generate this. This is just a class pointing to the CSprosh file of the thing that you referenced. This means that in Aspire, you can hook things up together in a hard-typed, strongly typed way. Going back here, you see that the API service also gets saved as a variable. And where we define the front end, we add a reference to the API service. What this will do runtime is Aspire will detect on what base URL your API will live. You will get that base URL, and it will inject it as an environment variable in your front end. That's the way service discovery works in Aspire. So nowhere in the front end code, and I can actually show you this, because there's this, you've all seen this template, right? It just calls fake weather data from the API. Going here. This is the base URL that's being set in the HTTP client on the front end. It's just called API service. There's no local hosts and then app settings that define everything per environment. It's just API service. Jumping back to the app host, this is the name that we give to our API service. This is the app ID. So based on that, Aspire will just inject the actual URL here as through environment variables. That's how it works. Now, if I run this, then you will see a fancy dashboard. There we go. And if you saw, these are the services that got defined, right? There's the Redis cache, there's the backend, there's the front end. When this started up, a bunch of those were in orange saying unhealthy. The status here relies on health checks, the default health checks that get added through the service defaults. And as long as they are not returning healthy, this will be in an unhealthy state, but it keeps updating. So now everything is running. This is my dashboard. So the source where everything is coming from, Redis is running in a Docker container currently, the different URLs where everything is hosted, and I have some actions here. I can stop and start every single resource that I have here. Meaning if I want to, I can just edit and continue my code from a backend, for example, and just restart the backend, and things will work. This was stuff that we did not have when we got started on the project. We had to stop the whole thing every single time for every change and had to restart it. Every service had to pop up. Even worse, our database also was defined in the app host, meaning that the connection string gets generated automatically as well, which is really neat. But there was no way to tell Aspire, do not spin down the SQL container, because it was SQL Server in a Docker container. So every time we stopped running our application, stopped debugging, the container went down. The database was still there because of Docker volumes, but we had to wait every single time for the container to boot up again, for SQL service to launch, to pull in the database again. That took a lot of time. All of that got fixed now, over time. There's a fun graph that's quite new. This has been here since 9.2, I believe. So this has nice animations, which is fun to play with, and shows the different connections. New in 9.3 is that you can right-click it, ask it some details, and of course there's AI in it now. Because AI, all the things, even the cameras. There's a console where you can just select whatever service, and you see the console output. That's fun. Oh wait, let me go here. Launch the front end. Pull in the weather data, refresh a couple of times, go back here, and then we go to traces. So these are all the live traces of my application as it's running. There's a bunch of stuff going on. There should be, here's the weather call. So here you can see that my front end, and you can click through on this, my front end did an API call, checked the cache first to check if the data is already there. Data was not there. So it went to the API to get stuff. And you can nicely see how long everything took. Going back to the traces, if we refresh, you see that it only goes to the cache and it gets data from there. So you can nicely see the flow of your application. Fun. Now, what we did was we integrated Aspire and Dapper together. Right? So all of this service discovery, we replaced that with Dapper service discovery because they do basically the same thing, only through the sidecar pattern instead of environment variables. So in order to do that, you can go to the app host, add a NuGet package called aspire.hosting.dapper, but that's not the one because it's deprecated. It's the community toolkit one. There's a community toolkit for Aspire as well, with a bunch of stuff, including Dapper hosting. Okay, so keep in mind, the Dapper demo I did was with YAML. You have to define everything in YAML, even though it was generated for now. So what I can do now, I can do, is it with? No, it's at. No. What was it? Build a web projects. Okay. Add Dapper sidecar. Why aren't you doing the thing? It's with Dapper sidecar. I always mix those two up. So this is the Dapper API built with Dapper sidecar. There we go. This is the Dapper UI. That's it. No more YAML. Aspire will now generate the Dapper run file for me in the background, and I will never have to see it. If I run this again, you will see that the dashboard has more entries. And those entries are the Dapper sidecars. See? And now it's nicely layered. So those Dapper CLI instances, those are the sidecars that are running. Now, if you run these things locally, then your sidecar is not an actual container. It's an executable that's running. If you deploy this to a container-based environment, then the sidecars run as containers. Just to show you what that looks like. Details. So there's Dapper and Dapper D processes running. Dapper D is the actual Dapper runtime. Dapper.exe is the sidecar. Okay, so Dapper is up and running now. Didn't need to do much for that. Meaning I can now go to my front end and I can add the Dapper SDK. Now, I'm configuring everything through Aspire, but in my client project itself, I'm just using the normal Dapper SDK. It doesn't need to know how I set everything up. It doesn't need to know that I'm using an app host, defined everything in C# instead of in YAML. Everything is just transparent for the SDK. All right, so this is the weather API client that you get by default in the starter template. It injects an HTTP client. It calls get from JSON, and then it parses that. That's what it does. We can replace this with the Dapper client, which is the SDK. So like this, rename all the things. Have to remove this, have to add that. Yes. Dapper client dot invoke method async, which means that we're doing a HTTP methods call. I'm expecting an array of weather forecasts to return. Needs to do a get method. The app ID was Dapper API, if I remember correctly. The method I'm invoking is weather forecast, which is really just the REST resource, right? So it's localhost whatever / weather forecast. That's the one I'm calling. Where are we? And then there's the cancellation token. That's basically it. Now we just have to jump to program.cs. We no longer need this because this is configuring HTTP client with service discovery. We don't want that anymore. Instead, we're doing builder.services.add Dapper client. This will register the Dapper client into my DI container. So let's add scoped, so what's it called? Weather API client. Now I have to register the Weather API client in the DI container as well, because that happens automatically with the add HTTP client before. But since we're not going through HTTP client anymore, I need that in there. Just to prove to you that I'm not lying about anything, this is the weather page. It injects the Weather API client and calls the get weather async. If I have 12 into that, we're at the part where we inject the Dapper client. So everything is hooked up. This is my API. This is the weather forecast. I'm just setting a breakpoint here to show you that we actually reach it. And then we'll see what happens. There we go. Everything up and running. Open the front end. Call the weather API. I'm in my backend. Continue. Everything is still working. Nice. Now, if I go to my traces in the Aspire dashboard, I take this one. Then you will see that my front end called the get weather thing went to the Redis cache. There was nothing there. So the get request got forwarded into the Dapper sidecar. That got forwarded into the Dapper sidecar of the API service to end up in the actual API service. This trace can nicely shows you how the sidecar pattern works. All right. So that's how you set up Dapper with Aspire. Makes it easy because you no longer need to do YAML. Now, for certain configurations, you would still like to have all the flexibility that the YAML config files give you in Dapper. You can just add that, and then through some of the Aspire methods, you can still reference that config file. I have an example of that, how we used it in the project, somewhere further in the slides. But from here on, we kept building on. Things you can do, for example, is storage builder.at Dapper state store. And then you can just say with reference storage. And now whatever I configure as state storage gets nicely injected, connection string gets injected into my API, or my front end in this case. Now, if you have a service running somewhere and you just need to add the connection string, for example, for application insights, you can do a builder.add connection string and add your application insight connection string right there. So all of that stuff just simply works. And then you can reference it here with reference app insights. And you can keep building on that. Now, the app host, in our case, got quite large. So we started splitting it up using extension methods. So it's also nicely structured for every project that we have. And jumping back here to show you our dashboards. This is an older version of the dashboard. This is not the one that I've just shown you. That upgrade hasn't happened yet. So you'll see the different executables that you see. Those are the Dapper sidecars. They are not layered underneath the containers that they're attached to, because that was a newer feature of the dashboard. But we have quite a lot of different stuffs in there. The top one has a type that says container. That was our SQL server, the actual server, because the bottom one was the database. So both show up in there, because both of them are defined as different resources in Aspire as well. You don't see it anymore. So you have the top record there, the container. Next to the name, there is now, but I blacked it out by accident, there's a pin, meaning that this has a persistent lifetime defined. So the container will not spin down if you stop running Aspire or your project, which saved us a lot of time. Stuff like that really improved our quality of life while we were building the thing. We got lucky to come into contact with the Aspire team because we were one of the early adopters. They wanted our feedback. We wanted to know where they were thinking of going with things. We spent a lot of time thinking of where does Dapper end and where does Aspire begin, because there's a lot of overlap between the two. And basically, we asked the team, and they didn't have a real answer to that either. And what we found out is that it kind of depends on what you want. You can go all in on Dapper and just use Aspire to hook everything up to avoid having to use a YAML, but you don't have to. You can mix and match whatever you want. So Dapper ends and Aspire starts wherever you want, what works for your project. Now, if you look closely, there's the state column, and there are two of them that are in the finished state. Those are worker projects, and those are entity framework migrations. Because because Aspire generates connection strings and injects them as environment variables, it's not as easy to do migrations as you would in a normal API project. So in order to tackle that, we put our migrations in a separate project, which has background workers. And those will start up, they will do the migrations, and then they will just exit with exit code 0, and that's why they come in a finished state and not in an error state. Now, when we first did this, when we first did this, there was no way for a resource to wait for another resource. Everything just spun up at the same time. Meaning, our API was trying to contact a database that was not ready yet because it was still being migrated. So we had to write a bunch of retry logic. And sometimes that retry had to reach 10, 15 retries before it could spin up, throwing a bunch of errors, stack traces in our output, in our logs. That got fixed because you can now add in your app host wait for. So resource can wait for another resource. That was a big quality of life improvement for us. It kept our logs a bit cleaner. That was expensive. We pushed this through to our container apps as init containers. Azure Container Apps is an abstraction layer on top of Kubernetes. Kubernetes has a thing called init containers, which is basically a container that will execute work, and only if it exits successfully, your main container will spin up, which sounds kind of perfect for migrations, so that's how we use it. Now, init containers do not show up in the portal for Azure Container Apps. If you just base yourself on the Azure portal, it looks like it's not supported. But through our Terraform setup, we were able to set it up, and it works. It works pretty well. And then if you go into the portal, you can export the resource as JSON. In there, the init container will show up. So that just works. All right. This is a snippet of our app host. So you see on top, add project DB migrations. That's our migration project being added. And then you have our API that references the SQL database. It references the storage, which is Azure storage. We inject environment variables ourselves, which is the authority of the identity server. In order to set up your OAuth flow, your OpenID Connect flow, you need to have that authority. And app settings is not really used because we are doing the whole service discovery thing. So you can actually create an endpoint reference, and it will inject the actual endpoint into your environment variable. And that worked. We have the sidecar, which we had extra options to because we were getting request times out when we were uploading PDF files because they were too big. Bunch of extra stuff there. And then we wait for SQL. We wait for the database to be ready. So if you would run that in the dashboard, you would see that it's in a waiting state until the database is spun up, and then it would start spinning up itself as well. So that's how that works. This, for example, is how you can still reference a Dapper YAML file. We have one that defines our file store to point to the Azure file storage or table storage, blob storage, sorry. And that's the way to do it. Okay, so that was a lot of talking about the whole development setup. And just to show you or to tell you how much this helped us, onboarding a new developer, going from git clone, opening the solution, figuring out what to start up, seeing that everything's connected correctly, that that the entire environment has been set up. You know how it is, right? It takes hours. With this, git clone, set app host as startup, F5, everything runs. First try, every single time. This saved us a lot of time when onboarding new people. So only for that, I would definitely use Aspire again in every single project. But then there's the deployment story. If you look at the official demos, then there's the azd up command. You define everything in your app host, azd up, everything gets spun up in an Azure environment. All your containers are being generated. There's stuff flying all over the place. Impressive demo. No one will use it that way. This is the new right-click publish. you run this from a developer's laptop. That's not the way to do it. Things have improved greatly by now, but this was the story when we got started. So we're in 9.3 now, and what you can do in the app host, you can now define that you just want Docker Compose files, or you want the Kubernetes files to deploy to, you want bicep files, and it will just create those files, which you can then check into a pull request and push them through your pipelines. Big improvement. Back then, that was not the case. So our deployment story was Terraform for the environment, which looked like this. So with Terraform, you first do a plan. There is a state file somewhere on Azure that contains the current state of your environment. The plan stage of Terraform will compare that state with your Terraform files, and then it will generate a Terraform plan, what it's planning to do. So this is a snippet, an example. You see the init container right there at the bottom, for example. Everything with a green plus sign is new stuff that will get added. Then there's a manual validation, and I cannot stress the importance of this. Always go over your plan before applying it, because sometimes it does really weird things. Once we go through the manual validation, it gets applied, you get an overview of all the things that get applied, and then it jumps to the next environment. That's how it was set up for us. Worked pretty well. Then there's the actual deployment of the different containers. Again, it's all containers, so there's a container registry in Azure that we push everything to. And then we just pull in, if you want to go from dev to test, for example, we just pull in the container image, we re-tag it for test, we push it to the next registry. We use the Azure CLI task in Azure DevOps to send the AZ container app update command. Container will spin up a new revision with a new image. We'll spin down the other one. Done. Update finished. Very, very little downtime. Works pretty well. Now, since we were maintaining our infrastructure with Terraform, Terraform not being a first-party thing for Azure, they were sometimes slow in adding features. And we had to work around that. An example here is, if you open a Blazor server application in your browser, what happens is it creates a SignalR connection, a WebSocket connection to your server. And all the updates that you do, all the interactions that you do with your web page, they go over that SignalR connection to the server where they're being handled, and the response comes back as a diff of your DOM. Since we're working with containers, there can be multiple instances. And the one that you're currently working on might crash and spin down, and you might be connected to a different one all of a sudden, which means you would lose your state, which is not something that you want. So in the Azure Container Apps environment, there is a checkbox that says enable sticky sessions, something like that, which basically means that if there's an existing session but you need to jump container, your session will move with you. That option was not available in Terraform. It was available through the Azure CLI. So we had an extra build step that every time we update our environment, we would run through our pipelines this command to enable sticky sessions. Just to show you what kind of things we had to work around because of technical problems. And that cost us time to figure this out. So, to conclude, .NET Aspire really helped us with our development loop. If you're working with different applications that need to start up at the same time, you need to onboard new people all the time, this will really help you speed up your process. Also, connecting everything together, not having to figure out what the real addresses are of all the services for every environment, having to constantly change app settings, make sure that everything gets injected correctly. Not having to do that anymore really helps. For Dapper, it worked as expected. The only downside that we had with Dapper, if you get exceptions in your, for example, in the demo I showed you with the method invocation, if you get exceptions there, the actual exception gets swallowed. You don't see the actual exception. You see this kind of really weird stuff in the console because this is going over gRPC. So you have to rely on logging and tracing to get the real exception, which is kind of more complex to figure out. That was a big downside. But apart from that, everything worked. It's technology agnostic, so if you're doing a project with different technology stacks, this will definitely help you. For future projects, I would almost always use .NET Aspire. Dapper, it would have to depend on the situation that we're in. So that was in short what our experiences were with the combination of these two technologies. I really hope that this kind of helped you to go beyond the demos that they've shown you and the getting started articles of Aspire. If you have questions for me, if you want to know more experiences of this, come talk to me. I'll be happy to help. I think we have time for a couple of questions, if there are any. No? Okay. If you want to see, if you want to go through the demo that kind of looks like the project, that's where to find it. And with that, I wish you a pleasant rest of the day, and thank you all for being here.
That's everyone jokes about how bright it is. It is actually bright. Um, Hello, NDC. Thank you for joining my session about the .NET supply chain. Um, we're going to see a lot of different attack vectors today in which you are directly vulnerable for once you do nothing with your .NET applications. And I once heard that a good presentation is as good as the time it takes for the first demo. So let's start with the first demo. So I have this program.cs file where I have this simple application where I have this class. For the people who are looking at me, I'm quite tall and I need to bend over. So if you see me standing in a weird position, that's not because I have a backache or whatever, it's just I need to adjust myself a bit. I have this class called person and I have this simple vibe coding. What I did, I just want to serialize this object to JSON and then log it to the command line. We'll see, hey, what could go wrong with this? I only use the, let's say if I do, for example, the .NET build, it will actually tell me, hey, everything's fine. I'm able to restore, it will compile, nothing wrong with this. So let's run it. And here you'll see, whoa. Well, you can imagine there are worse things that can happen than showing NDC Oslo what my worst taste of music is. I'm a Dutch guy, so I like Dutch music. It's not really in here, but yeah. But you can imagine if you look over the internet, there are much more examples of stuff happening to your application that you're not aware of, that it's introduced in your supply chain without you even knowing. Like for example, this malicious PyPy. Any Python developers here? Anyone who got their AWS key stolen by this package? No? It is serious threats. If you search over the internet, there are all kinds of examples of supply chain attacks and how they make us vulnerable. So how cool would it be that if I run that .NET build command, .NET will actually tell me, hey, there's something wrong. You should have a look at this, or you should have a look at that. That's what we're going to learn today, hopefully, and that's what my talk is about. So who am I? My name is Tom van den Berg. I'm a lead software engineer at a company called InfoSupport in the Netherlands. I work for the Dutch Railways for quite some time now, and there I build mission-critical software that makes the trains run every day in the Netherlands. So if you're ever going to visit the Netherlands and you have a delayed train, please don't call me. That's could be my issue, but hopefully not. Looking at history, the first time I came in contact with a supply chain attack was the SolarWinds attack. Not sure, did anyone heard of the SolarWinds attack? Right, where they built the software they built is called Orion, in which they provide certain features that is distributed to all kinds of governments all over the world. And the Orion software was breached via a supply chain attack on their build server. So hackers, people who want to harm, got access to the build server and they added a backdoor to the Orion software, which was distributed to all kinds of governments. And so the hacker got access to all the governments that had that software running. A more recent example was the one from a Microsoft engineer who saved the world. And what happened here was that there is this great XC utils package. I'm not sure if everyone heard of it. This is the contributor list of XC utils, if my internet loads. Is this the day GitHub doesn't work? Oh, there it is. Cool. Maintainer is this guy called Larzu. And what you see here is a new maintainer that joined like in 2022 for the first time. And after that, he made some commits over the years, and he became one of the maintainers of this XCutil package. And this guy, no one knows who he actually is, but this guy built a backdoor into the XCutils package, which is used in all Linux distributions all over the world. So you can imagine if this backdoor came into the Linux distributions that we're all using to run our software on, we would all be vulnerable for this. So I'm really thankful for that Microsoft dude who paid attention and saw this little CPU spike that he started investigating. But yeah, he might have saved the world from a very large supply chain attack. A new thing that occurred by the end of 2024 is the Cyber Resilience Act. Anyone heard of that? Not much people. That kind of warns me a bit, because there are a few things that you have to comply to according to this act. I think that you guys, that's the same as me, has a lot of issue getting non-functional requirements like security on the backlog of your product team. Like, why do we need security? Once it goes wrong, then we'll start looking. This new Cyber Resilience Act is actually solving that issue. It's by law, you are required to have a certain security baseline in place, and you need to report on that as well. So the first thing you need to do is risk assessments. And that means that you need to provide evidence that there are no known vulnerabilities in the software that you deliver. You need to have security reviews in place. There needs to be some kind of documentation on how is your process fixing those issues. What is the assessment that you did? And do you have a bill of material, the software bill of material, which we're going to talk about later. There are going to be assessments. So your company, your product will be assessed. And there are several classes where your software will adhere to. If you're lucky or not, you can do a self-assessment if you're in the non-critical parts. But if you're in the critical parts of this law, you will get an independent auditor that comes to your company and actually will audit if you adhere to this law or not. And you're obligated to do vulnerability reporting. So if you found a new exploitable vulnerability, you're actually obligated to report it to the European NDC. You can Google it, what it stands for. But why it bothers me that you've never heard of it is because within 1.5 years, so by September 11th, 2026, you are all required to have vulnerability reporting in place. So I'm not sure if everyone looked around a bit when we raised our hands, if anyone heard of this, but you have almost a little more than a year to get this in place. If it's still not on your backlog, that can be quite warning, right? And these fines, when the auditors come by and you don't have this in place, the fines are way much higher than the ones that you get from the GDPR violations. So just to wake everyone up, hey, there's this new EU law that you might need to have a look at. Cool. Then the supply chain. A supply chain, everyone heard of that word before? Like it's in the car industry, all the irons that are made, and the rubber that's being put into your tires, everything that encompasses your product is part of your supply chain. The same is for software. So everything that, all the materials, resources, and processes are combined in your product. And what's important in that is that 80% of the software that's currently running in production is no longer written by yourself. It's written by someone else, by some third-party dependency that we're using. Like, who's the .NET developer here? Okay, a lot of people. Who's a .NET developer that has never added a NuGet package to their project? No one, right? That encompasses, those dependencies are also part of your supply chain. And are you sure, do you know what those packages are actually doing? So looking at the .NET project, we have a lot of direct dependencies. And these are the dependencies that you directly put into your CS Proj file that you can reference there and the things that you see. But there are also a lot of hidden transitive packages that come by. Like if you, for example, include mass transit, a great example, you get a lot of extra transitive packages for free. And a few years ago, does everyone know Log4j and what happened there? Like the critical issue that was found there. I got called a lot of times by a lot of managers, all in panic. Do we need to do something? Do we have Log4j? Do we have an issue? I was not sure. I was like, it could be somewhere in this tree. I'm not sure. I don't have the tools to see that. But what happens if one of those transitive dependencies has a vulnerability? Well, .NET has some cool stuff for it since the release of .NET 8. I'm going to close this one up. So the first thing that you can just do is .NET list package include transitive. And this will tell you, hey, these are all your packages that your solution is using, including the transitive ones. Cool, right? Has anyone ever run this command to see what the tree actually is? Okay, cool. Something that's new in .NET 9. So let's say we have that log4j example, but in this case I take the system IO pipelines one. You have this new commando which is called .NET NuGet Y. And with .NET NuGet Y, you can actually ask, why do I have this dependency in my tree? So let's say I want to know where the system IO pipelines come from. It will actually tell me, hey, this is the tree via which I have this package in my project. If I've had this with a log4j issue, I could have just did this and then see directly, oh, I have a dependency on this via all these kinds of packages and I need to update them. But I didn't. I needed to go to Visual Studio, open the dependencies tab, and then open another tab and another, just to traverse the entire tree to see it. So something new. Who actually runs this kind of commands in their build pipeline or when they're developing locally? Oh, you do? Okay, cool. I don't want to do this. And that's why in .NET 8, there has been an introduction of NuGet Audit. And NuGet Audit is I'll just first show what this is doing. So I disabled it for demo purposes. The default configuration for .NET 8 is that it's on. So if everyone is on the version that got released of Visual Studio with .NET 8, you might have seen in your file explorer, you might have seen this warning where it states, hey, this solution contains vulnerabilities. That's this feature, which is enabled by default in .NET 8. So for now, if I do .NET build, for example, I will get warnings. And the warnings will actually state, hey, there are vulnerabilities found in packages that I have. At the same result that I would get if I did, for example, .NET list package vulnerable. See? Both the same result. Information that you will get from this is quite cool. I have a serious issue, so this. Okay. If there's a patch version for it, you can see, hey, I need to update to this, at least this version. You can, for some exploits, you can even see, is this all readable? I'm not sure if it's, yeah, good. Okay. For some exploits, you can even see, hey, this is how you can exploit it. So if you have any bad intentions, you can actually see, hey, this is the way I can misuse it. But what's really cool is a lot of people did, for example, the following. They treat warnings as errors. Everyone heard of that? Where you just say, hey, if I have a warning in my build, I can fill my build with an error. So the result of this will actually be, hey, build failure. Cool. Local development, I get at least a build failure when I have a vulnerability in my package. Well, that's the first step. In .NET 9, what's good to mention here is the audit mode. And audit mode is currently set to direct, which means it's only scanning your direct dependencies, so the ones that you have configured in your C Sports file. It's only scanning those ones for vulnerabilities. It was the same case at the first release of .NET 9. And in the second release of .NET 9, they changed this to all, which means I want to scan all the dependencies in my entire tree for vulnerabilities. This broke a lot of builds, because you can imagine if I have this treat warnings as errors set to true, and I get back onto work on Monday morning and they updated the .NET 9, and I updated to .NET 9.02, I got a breaking build. So they reversed that, but with the introduction of .NET 10, the default behavior will be that NuGet audit mode will be set to all. So once you update the .NET 10 preview 4, or when it comes out in November, you will actually have all your dependencies scanned by default. And the last thing that we actually have is the NuGet audit level, in which you can state, hey, I want to break my build on a certain level of vulnerability found. for demo purposes and to not have all kinds of errors and stuff that you need to filter out, I'm going to disable this again. Because another thing that was newly introduced in .NET 9 is the following. Restoring a project now outputs certain variables. And one of the variables is the project count. So how many projects are actually restored. And the second thing it outputs is how many of those projects are actually audited. Which means if I now, for example, I've disabled the vulnerability reporting on that project, and if I do now, for example, my .NET build, it will actually give me an error of a warning and says, hey, restore did not audit project. Not every project in the solution. Expected 1, found 0. So you will actually get information if your auditing has been done correctly, or did it miss anything. What's good to mention also is that if you're, for example, anyone who is only using a private feed for the NuGet packages, I see not so much people, so most of you are using the public feed, I think. But what you can do, or what you must do if you, for example, use a private feed only, is that in .NET 9, no, wait, one step back, the vulnerability information that .NET uses to give you the information is pulled from via NuGet, the public NuGet organization, and then from the GitHub advisory thingy. But if you have only configured a private feed for your packages, you won't get access to that information because you just completely killed the line to the public NuGet feed. What they added new in .NET 9 is this audit source thing, where you can actually say, hey, I only have a private feed configured for my package that I want to use, but for audit information, you can actually use the public NuGet feed. This audit sources is not used in, let's say, if I do the .NET list package is vulnerable, this is not using this audit sources configuration yet. They're still working on that. Okay, audit sources. Cool. Then we might be more secure, right? We have found out if we have any vulnerabilities there, we fix them. What could otherwise go wrong, right? Well, one of the things, was there already someone doing, who was doing IT before in the year 2008 already? I was not, I was barely walking then. No, that's not entirely true. Cisco, you know Cisco, the ones that built those little small routers that you had at home, the little blue thingy from earlier. Cisco was the first company, one of the first companies that actually got sued because they were using some kind of license in their software that forces them to open source their product. So this means that, let's say, if you look at the entire tree, one of those dependencies had a license in them, which actually states, hey, the use of this license will enforces you to open source the software that you use it in. And if you're using this in your core domain, like Cisco was doing, you were forced to open source your entire business product, the thing that you make money from, where competitors could be very interested in just taking it over. So you might see in the case of Cisco that there was a general public license somewhere down in a package that was very, that was published under this license, so they were sued. In the end, they actually got, they settled. It never came to an actual lawsuit, but yeah, they had to open source their software. Cool. So this is an issue for each and every one here. Has everyone heard of the license trap before? Does everyone know what type of licenses you have actually running in your current software? And do you monitor for it? So Linksys was kind of an Cisco was kind of an interesting company for people to sue, because they had a kind of, I'm not sure what it actually was again, but they had this, they fixed something in Linux, I think it was, for some kind of networking stuff, where the whole world was actually waiting for. So they were kind of an interesting company to sue and let them open source their software. But currently there is even a company now which is actually exploiting all these kinds of license violations by actually suing people, suing companies that use this type of licenses and don't open source their software. Oh, I have a different view. So let me show you how this works in .NET. .NET itself doesn't really have a tool for this yet, so I'm going to use Trivy for it. But what you do need to do is need to enable my package log file, and I'll come back to later what this actually is and what this means. But this will generate a certain file which contains all kinds of information about my dependencies. So if I now, for example, run Trivy with a certain scanner, everyone heard of Trivy before? Like, it's an open source scanning tool which scans for misconfiguration, vulnerabilities, licenses, all kinds of stuff you want to scan. Scanners, a license. So this will actually tell me, hey, I found your package log file, and these are the licenses that you're currently having via all the dependencies that you're pulling in. That's something you can just run today, tomorrow, when you get back to the office and see, hey, what kind of dependencies and what kind of licenses do I actually have? In this case, I only have the BS3 and the MIT one, so the severity is kind of low. But you might see if you have other licenses in your software, that it will actually tell you that you might have an issue, and that you might need to look at some certain stuff. Cool. And that's why one part of the Cyber Resilience Act is having risk assessment in place, having supply chain risk management, which means identifying, assessing, and prioritizing all the risks that you introduce by adding dependencies to your software. So you can think of, for example, operational risk, financial risks, business continuity risks. Do we want to trust that open source maintainer from Nebraska always will support this package and my core business will rely on it? Or do I need to write it myself? A great example of this is, I know it started out as some kind of geek thingy. I'm not sure where it is. Has everyone heard of the is-ought package from NPM? This is quite a cool package. This tells me if a number is odd or even, right? It has almost 400,000 downloads a week. And what's really cool, if you look at the code, it's like 13 lines of code. So if your core business relies on a package like this, you might want to see, hey, isn't it better to implement it ourselves? And spend some time on it to implement it. It might not even be that hard to do. And what's really cool is that this one also has a dependency to isNumber, which has 92 million downloads a week. And this will actually check if the thing that you have is a number. Right? Like, why would you trust on this? Do risk assessment, see why you use certain packages, and make sure you use it in the right way, and that you accept the risk that you introduce with them. Cool. So we figured it out. We have to fix the license trap. We don't have any known vulnerabilities in our software. Cool. We're safe, right? Not entirely, because I just asked how many people are just using a private feed, how many people are only using the public NuGet feed, how many people have some kind of combination like this, where you have a private and a public feed. Oh, cool. Two types of supply chain attacks I want to discuss with here. The first one is dependency confusion. And looking at this, let's say, for example, I have this package, my cool package that's being used, and that's being published to my own private feed. And if you say, hey, NuGet, restore my packages, what NuGet will do is it will send an asynchronous request to all the configured package sources, and the one that has it returns it, right? That's how we're currently doing this. But what's the issue with this is that NuGet sends an asynchronous request to all package sources. And if I say, for example, hey, I will publish as a hacker or someone who wants to do harm, if I publish a package to the public NuGet feed that has the same name as the package that you are using, and then rely on the internal working of NuGet that selects the package or the package source that returns the fastest response, I'm just going to wait and see when you are going to pull my package instead of using your own. Right? This is a serious risk that everyone, saw a lot of hands where everyone's currently actually vulnerable for. Another thing, who uses wildcards in their references? Oh, that's great. Oh, only a few people. But the same is for wildcards, for example. I can just upload a version that's way, way, way much higher than the one that you're currently referencing, and you will always pull my package, for example. So dependency confusion. What I will demo is what NuGet has in place to be more resilient against this. And the second thing is the typo squatting attack, what I will show you. So the first thing that you can actually do, and I'm really curious how many people already did this. This is just a public NuGet feed. And the thing that you see here is this prefix reserved keyword. Has everyone ever seen this before? Cool. Prefix reserved actually means the prefix, and you can define yourself what your prefix actually is, but in this case it's the prefix Newtonsoft, is reserved for the company or for an identity that solely has the rights to publish packages in that name that contains that prefix. So you can imagine, I work for the Dutch Railways, in short it's NS in the Netherlands, that I want as a company to claim the prefix NS so that no other person or whatever can publish a package to that feed in my name. It has that prefix of NS in the beginning. Now, if you click on this, you will actually be routed to the process of doing this. And the funny thing is that it's quite a weird process. It just starts by sending an email to NuGet. Like, what? But yeah, package prefix claiming. If you're using the public NuGet feed and the private feed, I would definitely recommend you doing it starting from Monday as well. The second thing that you can do against dependency confusion is in your NuGet file, in your NuGet configuration file, there's this thing called package source mapping. And package source mapping is actually a mapping of where you want to pull your packages from. So let's say in this example, I harmed myself a bit by using my own version of Newtonsoft JSON that I altered a little bit. But to show you what it actually does, if I move it to here, for example, and what I first need to do, so NuGet actually uses a local cache as well to restore packages. And the first thing it actually does is check that local cache if the package is actually there. And it doesn't really matter from which source it actually came. If it's present in your local cache, it will use that version. So now, because I have my malicious version of Newtonsoft in my local cache, I cleared it. And if I do, for example, now a .NET run of my project, and then it needs to restore everything again because I just cleared all my cache, which takes a bit longer. Oh, this is correct because I still have my package log file enabled, and you already saw the demo of what the package log file is about. I'm going to disable this one and delete that one, which we'll come back to in a bit. But now again, cool. Build succeeded. And it actually outputs without changing anything in my code, I just changed package reference where I want to pull this image from, where I want to pull this dependency from. It actually works, and it does what I expect it to do. So, package source mapping. Then, I'm a CLI guy. I use a lot of Visual Studio Code and the CLI. Are there people who add in to use the command like .NET add package, for example. Are there other people who add packages like this, or do you always use the Visual Studio thing? Okay. Typo squatting attacks actually do as the name says. They rely on people making typos. Like, for example, in this case, I want to add the package poly.core. You already saw me make a lot of mistakes typing this small sentence here. But what I can do as an attacker, or if someone wants to do harm, is I can publish malicious packages to the public NuGet feed and actually introduce some kind of typo in the name, where I will rely on people actually making mistakes in adding those packages and attack them via there. So I can just publish this one and make a reference to the actual poly core package. So the functionality will always be the same. But I do have a package that's mine and not the one that you're expecting to be. So something you can do against the typo squatting attacks, and that is also in my NuGet config file, which is signature validation mode. And with signature validation mode, you tell NuGet to validate the signature of a NuGet package that you're actually using. And this uses the trusted signers that you can configure in your NuGet config as well. This will actually check, let's say, for example, I have an author or a certain repository. There are two different types of trusted signers that you can add. But one of those, the package that I'm pulling in, needs to have a fingerprint that is the same as the one that I have configured here somewhere. Otherwise, it will actually fail. Now, what's interesting, are there any .NET MAUI developers here who are also publishing to Apple, macOS thingy? No one? Wow. Trusted signers is currently broken on macOS. There's this bug that has been there since 2022, where Apple made some kind of changes in the encryption they do on Macs. So I can just remove a, let's say I'm going to remove it here. And then my project will still be working. But if I go to my Linux build server, for example, where I also ran this example, it will actually state, hey, you're not able to do this because some kind of trusted signers are actually missing. So it doesn't work on Mac. There is this bug on NuGet, on GitHub, that you can find more information about. I will link after.
This is, in theory, very simple. You just need to get the fingerprint of all the certificates and all the authorities and all the suppliers and all the feeds.
Yeah.
And that sounds like a lot of work.
It does.
How can you get this easily?
Yeah, there are two ways to add these trusted signers. If you add the signature validation mode and then just run your software, it will actually state, hey, these are the packages I'm trying to, sorry, did everyone hear the question? Sorry, I'll come back to the answer. The question actually is, hey, we have a lot of NuGet packages there and a lot of dependencies that are into there because it's all from the entire tree needs to be configured. How do we do this? There's a lot of packages there. How do we fix this? It's quite some work, I can say that, but yeah, security needs some attention as well. What you can do, there are two things. You can use the .NET trusted signers command. I'm not sure by head what it is, but there's a command where you can just reference a certain package that you want to trust. Or if you remove it like this here, it will actually output the hash of all the packages it will download and then add it to here. So there are certain ways that you can find out of it, but it does take some work. You don't have some kind of wildcard that you can just add and then it magically works. Is that an answer to your question? Ish. Okay. Maybe come back after to discuss it a bit more. Typo squatting attacks. Add trusted signers to be sure that the packages that you're actually pulling in are from the publishers that you will actually expect them from to be. Cool. Now, we have fixed all local vulnerabilities. We're sure that the packages that we're actually using in our local development are the ones that we expect them to be. We have checked all licenses and everything's okay. We're safe, right? What's interesting is that we then push our software to the build agent, and agent goes beep, beep, boop, 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 and there comes some kind of binaries out of that. And for .NET, there are, no, one step back. What you want to have is that the binaries that come out of your local deployment or local development are the same binaries that come out of your build agents, right? They need to be the same to be deterministic. And deterministic builds are called reproducible builds, and there are a few things that actually influence the outcome of that build, which is the installed .NET version, so which SDK version have you installed on your build agent and on your machine. What packages are being used, what versions of packages, what's the content of them, and what's in your local cache. So you can see, for example, in case of the SolarWinds attack that I described in the beginning of this talk, that there was some kind of malicious package added to your local cache, which was then being used in the restore process, which you are not aware of because it's running on your build machine, and you don't have stuff enabled to check this kind of stuff. That's kind of hard. Like the build agent is actually a attack vector that you need to, of an attack service that you need to secure as well. So reproducible builds. What's in it in .NET? There are a few things. Let me take this a bit back. Yeah. Okay. One of the first things we need to do is the package and go back to the package log.json. So the package log.js, who's not enabled the package log.json in their project? So everyone knows what the package log is, and cool. For the ones who don't have it, it will generate a log file, and that log file contains certain versions, the version that's being resolved and the content hash of the package that's being resolved. And if you then, for example, this log file, you need to check into your source control, and then what you can do is do a restore including that log mode, which you actually say, hey, I want to use this package log file to restore my packages and check all the stuff that you restore to the content that's being described in that log file. So in this case, I didn't change anything. I still have that warning of the restore did not output, but my build succeeds. But if I, for example, say, hey, I want to use a newer version, if I get access to the build agent, I say, hey, but my malicious package is 13.04, and I update it before the build actually starts, and I run this again, and we already saw it in the previous run, it will actually fail my build as well. So having 7 different dependencies locally on the build server, this will actually fail your build for that. And we'll make sure that you have the same binary outputs as well. Another thing that, oh, that's the wrong one. Another thing that happens, that can happen, or can influence it, is the software that's already present on that build agent. So there is this amazing package which is called .NET Reproducible Builds. And there are a few things I want to highlight from that. And the first thing is this netcore target pack route, in which states that the .NET build will actually sniff out installed software on your machine and use that runtime, the .NET runtime that's installed to create the binaries, create your package for you. But the runtime can be messed with as well. I can log into that folder that's being described, and I can alter the runtime there. And the thing that you can do is this netcore targeting pack route, set it to undefined. What MS-Build then will do, it will pull in a NuGet package which contains the runtime that's being used for building your binaries. So this is what you see here. And to show you that it actually works, let's say, for example, if I go back to my NuGet config file, that's why I have all these configured here. Oh, let's say, back. Let's say I remove those. Remove all my local packages, and then say .NET build. See? And now it actually states unable to resolve this package. Package source mapping is enabled and it's not configured. So putting this back. So this will actually use, and these NuGet packages are also part of your package log file, in which you can just say, hey, and they are being checked in the process with trusted signers, and everything that I showed you before is also used in this process. So you're sure that the NuGet packages that I use locally to build, the runtime packages that I use locally to create my binaries, are the same ones that I'm using on my build agent to create the binaries there. And the last thing for this I want to show you is there's also this implicit NuGet fallback. You have that NuGet cache where you can put stuff for. You can disable that by setting these properties. Okay. So what we actually did in the past 40 minutes, I think, is create a secure by design .NET solution where we have NuGet audit in place to check for vulnerabilities, claim the prefix where we don't allow other people to actually deploy certain stuff for us. We checked for all the licenses that we have in place and if there are no known issues with that. We enabled package source mapping to make sure that everything comes from the right place. Checked for pre-installed software and used the specific ones that we defined. Saw the package log file that checks the content hash and if it's the same package is correct. And we saw the NuGet cache and what can happen with that. And we disabled it. So what we actually did is create an automatic or a secure by design solution where anyone can just add a package. And if it's a trusted package, it will just work. But if it's an untrusted package that comes from a separate source that you don't expect it to be, it will automatically fail. So by default, anyone who wants to work with this has a more secure way of using it. So if you have any junior developer or whatever, it can't just add some kind of a random package and then break the whole stuff. So what's more importantly in this is that you also need to create transparency. Yeah? And for the Cyber Resilience Act, we also stated that the service bill of material, of the software bill of material, is a real thing, and that needs to be report out. You need to report out on that and show what's all there. So to show you what is actually a bill of material, I will use Trivia again. And for this, I will include the license scanning and the vulnerability scanning. So running this. Let's see if I have my package log still enabled. Yep. Okay, this outputs my JSON file. And what's good to mention is there are certain different types of formats for SBOMs. We're not going to dive into that, but the ones that I'm using here is the Cyclone DX one, but there is also SPDX. They have the different strengths, a lot of overlap in them, but yeah, they have different use cases. So what's interesting is that this information contains all the licenses that are being used in your software. It contains all vulnerabilities that are being used in your software, and you want to report out on this. But what is something that's quite newish is an SBOM related concept, which is called VEX. It's the Vulnerability Exploitability Exchange. And what VEX actually does is it puts all the vulnerabilities that you have in your software in context for the end user, for the ones who is using your software. So let's say we have this vulnerability and SBOM combination, which says, hey, I have like 200 vulnerabilities in my system. If I then add a VEX for it and see, hey, what of the 200 vulnerabilities that are actually there are exploitable in my software, I can slim it down to, for example, 5. So let's say I have 100 vulnerabilities that are found in packages that I don't even ship to my customer. And another 50 packages of another 50 vulnerabilities are found in endpoints that are not even exposed to the outside world. What type of vulnerabilities are actually exploitable for the end user? That's what we want to report out on. And those are the interesting vulnerabilities as well to fix at first. So that's the combination of an SBOM file and VEX. There's a lot of more information to find about it, but I want to at least touch upon the subject and let you know that it's out there and something you need to look into. And the last thing I want to show you is Salsa, which is an open source framework provided by Google. It contains a checklist of all for the entire software development lifecycle, where it states, hey, for each part of this lifecycle, what are the attack surfaces that you have, and what are the things that you can do to actually be more secure in your entire process. To round up, what we've learned, we've seen different types of supply chain attacks in .NET and how you can fix them. We've seen supply chain risk management, where you actually need to have some kind of process in place to determine, are these the dependencies I really want to add. Secure by design implementation in .NET with all the examples I gave. And creating transparency by creating an SBOM file and reporting out on it. But you can't forget everything, and it's all important to fix. But if there's one thing I want you to remember, and I want to create a call to action for it, is get started today to run your .NET list package, include transitive vulnerable for it, to see if you have any vulnerabilities in your software and start fixing them today. Thanks for listening. That was my session.
Hey, great. Okay, let's see, everyone settle down. Awesome. Hey, everyone. So super happy to have you here. Did everyone have a good lunch? Is everyone, or are we having a dip, or are we good? How are we feeling? Good. Yeah, we're good? Awesome, awesome. Okay, so my name is Sander ten Brinke. I'm very excited to be here. It's my first NDC Oslo as well, so I've been really looking forward to be here today. And in this next hour, I want to teach you everything that you need to know about configuration and secret management in .NET. And then you might be thinking, like, why this topic? Like, I've used iConfiguration before. I know how a database connection string works. Why talk about this? So the reason why is because the way that the .NET configuration system works, it's very flexible. It's very powerful. But I've also seen a lot of companies do a lot of different things, a lot of different projects, use it correctly, use it incorrectly, use it like suboptimally or even insecure. And so I want to tell you everything that you need to know about the modern system, the do's, the don'ts, etc. So I think we have quite a couple of Dutchies in the room. Any Dutch people in the room? I think, that's quite a couple. I thought more, but whatever. Anyway, I'm from the Netherlands. And in the Netherlands, you might know, we have beautiful flowers or tulips. We have stroopwafels, so if you want a Dutch cookie afterwards, come to me. I have stickers here as well. And we're also very known for our bikes. Well, very, very interesting. We also have the Dutch tax administration. And you might be wondering, why would I talk about something as boring as the Dutch tax administration? Well, I'm not going to bore you with this for an hour. It's because it's a part of an important story about secret management and how companies are doing this. So in 2021, December 2021, there was a Dutch white hat hacker, and he was looking around at the GitHub profile from a Dutch tax services employee. And in there, he found credentials to a private GitLab account. So he was like, okay, I'll just clone that and see what happens. Must be nothing bad. And in there, he actually found like a file with tons and tons of passwords and usernames for lots of services from the Dutch tax administration, including a global Azure admin account. So you can guess where this is going. So what he decides to do is, of course, try to log in. Well, he was writing the email at the same time, right? He's a good guy. Let's not blame him. But he immediately goes to the Azure portal, username, password, correct. But Netherlands, right, we're a very good country. We have it secured with MFA, which was also accepted after like 5 seconds of waiting. So within minutes, this guy had global Azure access to one of the development environments. And yeah, all because of like incorrect secret management. That is how easy it can get. And luckily, this story had a pretty happy ending. He immediately reported it to the Dutch tax administration. He got a trophy sent home that said, I hacked the Dutch tax administration and I never got a refund. All right? It's crazy. This is really funny. I'm glad it had a happy ending, but it's also so simple to make this mistake. Because people think, oh, this is just, we don't make these mistakes. Big companies have this under control. They don't, right? Samsung, March 22. And the thousands of secret keys were found in a leaked source code. Because some of their repos were leaked. They were storing their secrets right in plain text in there. Boom, you have a problem. January 24, last year, Mercedes-Benz's source code for their UI, for their dashboards, was actually exposed because there was a GitHub token somewhere. And someone got that token, cloned their repos, and yeah, everything got leaked. And who remembers this, right? Can I get a hands up? Who remembers this Rabbit R1, this AI device? Oh, okay. There's not that many people. I thought there'd be more. Okay, so for people that don't know this device, this was like a device that released last year, and what it allows you to do is it's like a little AI assistant, right? You put it on your clothing around here, and it's supposed to kind of replace your phone. So you can just talk to it, and then it will do all of your AI tasks for you. Sounds cool. Under the hood, it was just an Android app, and it was also very, very insecure. So some researchers did some research into it. They looked into what is happening on the device, found API keys that ultimately would allow them to brick all these devices all over the world, just because they had these API keys. It's crazy how this keeps happening. But it also gets a lot worse, right? GitGuardian is a company around Git security and stuff like that, and they produce a report every year around the state of secrets. So in last year, 24 million secrets got committed into GitHub publicly, right? 70%, let's see what this says. 70% of valid secrets detected in public repositories in 2022 remain active today, so 3 years. 4.6% of all public repos contain a secret, 35% of all private repos contain a secret, and 15% of all commit authors have committed a secret before. So before I introduce myself and really get started, let me ask you, have you ever leaked a secret? Can I see some hands up? I thought there'd be less people that were kind of, hiding in their chair, but you guys seem really proud of this. Like, yes, me, pick me. Well, it is just a really easy mistake to make. It's a rite of passage. Everyone has done this before. And today we're going to learn what you should do, what you shouldn't do, etc. My name is Sander ten Brinke. I'm a senior software engineer and a knowledge officer at Arcadie. We are a Dutch IT consultancy company, based in Zwolle, the city where I'm also from. And there I do a lot with .NET and Azure consulting, and I have also done a lot with app development and cloud, DevOps, front end, lots of different stuff. I'm an MVP, so I love speaking, blogging, doing open source, podcasting. If you want to learn more about me, look me up. Every session that I give, I will probably also repeat this at the end. Every session I give, I always write a blog post. So if you want to share this with colleagues or you want to watch it back or whatever, scan that QR code. You'll get everything that you need to know on your phone or just in text form, basically. For people that want to scan it later, you'll get it. You'll see it later again. So let's talk about the agenda, right? I'm always telling people, hey, let's interrupt. Let's make it a conversation, a dialogue. Just me sending and broadcasting for an hour is going to be difficult. It's also going to be a lot of people, so let's see what we can make happen. Maybe a couple of questions throughout, but otherwise we'll save it to the end or afterwards. Anyway, the basics of configuration is what we're going to cover first. So what does that look like? Why is it important in .NET, etc. Then we're going to forget that because we should really be using the options pattern instead. Furthermore, we're going to talk about dealing with secrets during development, and then we're going to push to production and talk about some on-prem and also Azure services that help us deal with secret management and configuration management in production. Okay, the basics of configuration. Let's first quickly talk about configuration and why it is actually an important thing, to have. Because configuration, I kind of see it as the settings screen of your application, right? Like we have all of our endpoints, our logic, our UI, our whatever, but we also want to tweak things, right? Logging settings, maybe some API keys, feature flags are of course very, very important. And we can tweak these things maybe while restarting or redeploying our application without having to make any source code changes. And it's a given, I think everyone uses this, but imagine a world without configuration management, right? We need to either have everything hard-coded into our code and then have lots of if statements, or we'd probably, just put secrets in our code and every environment gets a new build with new secrets. It's super insecure and very annoying to use. So it's great that .NET has a configuration system. And in the new .NET, so I'm talking since .NET Core, it kind of looks like this, right? The core of the system here is an interface called iConfiguration. And this abstracts all kinds of configuration providers away from you. So there's appsettings.json, it's very familiar probably, appsettings.development.json, environment variables, command line arguments, and other sources, right? XML files, ini files, TOML, YAML, and even if you want cloud providers or the ones you create yourself. And this is all abstracted away. So when you're using the configuration system, you do not know what provider is actually giving you that data, which makes it very, very flexible. So what does that look like in code? So at the end of this presentation, we're going to do a couple of demos, but this presentation and the slides are also very code heavy. So we might have some code somewhere that has an interface instance, a class instance of iConfiguration, right? And we have a method, getAPIKey, and this would be configuration.getValue, generic type, well, in this case, string, API key. So you're telling the configuration system, please go through my configuration, find something that's called API key, and return the value to me as a string. You could also use the indexer pattern, right? So you could say just API key. This will also work. It's just that this will always return a string to you. And that's quite good. That's quite great. I feel for other languages like Python, Java, Ruby, Go, etc., it will probably look kind of the same, right? It's just some not at all. Okay, I see the Java person disagreeing. Anyway. Okay, it's not like that, but it is very understandable. I think we can agree on that, right? It's great, awesome. So the one thing that .NET at least does very differently, in my opinion, is that we have support for configuration structure. Right, so we can have different kinds of files like app settings.json or other providers. And by the way, all providers support structures, some just in different ways. But app settings.json is the most logical one. So we have things like logging, so log level for different kind of namespaces, allowed hosts, connection strings to your database, and features, right? So these are all like objects with nested values. And we can actually use this in different sections, right? So instead of like talking to the entire configuration system, we can obtain configuration sections and then do the same operations on those, right? So we could say, hey, I want the features section. So we can say configuration.getSection or configuration.getRequiredSection, right? Like write these right here. And this will then return an iConfiguration section, and this provides the same API, right? Like a get value or the indexer and stuff like that. And one little note, getSection will return an empty object when the configuration is not found, whereas getRequiredSection will throw an error, like it will throw an exception. I always tell people, please use the getRequiredSection because your configuration system is very, very, well, it's not going to change a lot at runtime. Maybe you change some values at runtime, it's really cool, but your structure is not going to change. So getting like an empty object back is, to me, always like almost always invalid behavior if you're just using a normal system. So getRequiredSection is always my default. But you might also not want to have lots of sections and get section by section and section and section. You might just want to get like a value, like a nested value. So now we can say features, colon, and then I say enable new UI, and now we can get like a Boolean out of there as well. Right? So we have iConfiguration, we have configuration sections. Later on, we're going to talk about why you shouldn't really be using this in your classes, but it's important to know. So then how does this work? How do we get an iConfiguration? Well, the way we do this is by creating like a configuration builder or like a configuration manager. We add providers to it. We call builder.build. And at that point, we end up with an iConfiguration root. And this is the same as an iConfiguration, but it also has a list of providers. You're never really using iConfiguration root. It's also not a part of the dependency injection container by default. But now we have that set up. So in code, right, create a new configuration builder, add environment variables, add JSON file, and then build. But then that begs the question, if we have multiple providers, how does it know what provider to use if we have like a duplicate, right? What if shared settings.json and app settings.json and maybe even environment variables all contain a value for a specific key? In that case, the order matters, right? That's kind of how you're going to work with the system. So here you can see that environment variables was added last, and because this was added last, it has the highest priority. So it's first going to take a look in environment variables, then it's going to search in app settings.json, then it's going to search in shared settings.json. Okay, and that then begs the question, right? We get iConfiguration, but who here has actually, okay, so who here is using iConfiguration somewhere in their project? Like basically almost everyone except the Java developer. No hate, Java is great. It's just, you have to get some interaction in here, right? Great. So who here has used Configuration Builder? Okay, a lot less hands. So how does that work? And that's because .NET creates a lot of default setups for you. So when you're using like host or web application class in the newer versions or just the generic host thingies, it will create a default setup for you. And this default setup looks as follows. Right? We have an app settings.json, which is added as the first one, so it has the lowest priority. And this is where you're probably familiar with this in like ASP.NET Core projects, in worker services, and here you can store some configuration. Then there's the app settings.environment.json. And this environment is quite special. There's going to be an environment variable on your system called .NET environment or ASP.NET Core environment. And this value will be in that environment thing. So it's going to be app settings.development.json by default. The reason that works is because in your projects you have a properties/launch settings.json file. And in there for the current process, it will always set this value to development by default. So that is why you always have an app settings.json and an app settings.development.json. It's really useful because for test environments, we can set this value to test. And then for staging and production, we can set it to like staging and production. And now we can easily override configuration per environment. It's really, really handy. We set some defaults in app settings.json, like feature flags, like the new UI, we enable it on development, but we disable it on production. But there's also user secrets, and we're going to talk more about this later, which is only enabled during development. So this is the way, and this is where you should be storing your secrets, like your API keys, your database connection strings. This is where you should be storing your secrets in during development. There's also environment variables, right? So you can use that as well. I don't really often use that during development, but especially with Docker and Kubernetes and stuff like that in containers, you're often using environment variables to set these things, the configuration. And then there's the command line arguments. So this is like the highest priority. Even if all of these providers have something like a value for key, the command line arguments will always win. So it's like the final, it's the final hurdle, the final thing that it'll check. So this is the default system. And I feel like, who was aware of this system like this? I see a lot of hands, but I don't see as many hands as people that use configuration. And I feel like sometimes when people are confused about where configuration is coming from, how they should store secrets, in what provider, and this is an important one to remember. And we're going to talk more about that later. So that is something that makes secrets, the way that .NET developers store secrets is very flexible all over the place, because I feel like that is something that is basically a little bit misunderstood. So it's time to talk about the options pattern now. And you should basically forget everything I told you except for that last couple slides, because you shouldn't be using iConfiguration and iConfiguration section in your code like this. Let's take a look at something cool. We're looking at some configuration, right? So maybe in our app settings.json, and that's external API settings, right? So we have a API URL, we have an API key, we have a timeout in milliseconds as well. And wouldn't it be cool if we could now create a class and treat this as code, right? So we could create a class with the exact same properties, and now we could maybe just inject that into a class. So the class might not even know about the fact that this is actually coming from a configuration system. We can add methods to it, we can unit test it, we can do really fun things with it, pass it around. So let's do that. Let's make use of that powerful system. Is this readable for people in the back? Yeah, I see a lot of, yeah, thank you so much. Awesome. So we have a class, external API clients, right? And this is going to need the external API settings. So we're injecting iConfiguration, and we're then storing that somewhere in a private field. And now we're going to call an external API. So we're going to need some information. So we're going to say configuration, get section, external API settings, get, and then we're going to cast that to a generic type, external API settings. And this will then go through the configuration system, look for like a property with that same class name, look for all those properties in the class in the JSON, map those, and then give you back a class instance. And now we can treat it as code. Maybe you already have an instance of such a class, and you want to reuse it or you want to enrich it. So you can also say .bind and pass in an existing instance and kind of reuse it as well. And now you can do something with these settings. Just, is there anyone here that sees some problems with this approach? Someone that is in distance of me hearing things as well, because it's really far away. You have to repeat this in all of your classes. I do agree. That's not something I found that I'm going to talk about, but I do think it's something that I might need to add to the slides. So that's a good one. Thank you. All right. So let's move on. Let's move on. The problems that I see here is that this class has access to iConfiguration and thus can access all irrelevant configuration data as well. This class is able to retrieve settings around connection strings to your database, logging setting doesn't need, feature flags that it doesn't need, or whatever. Now, it's not going to be able to change them, but it's still weird that it has access, because what if we change our configuration structure, right? That's the second problem. If our class has knowledge of the configuration structure, because it knows it needs a configuration bit called external API settings, maybe we change it. Maybe we change it to external API options. And then at runtime, this class is going to break. Maybe it's going to break because it used configuration it didn't actually need. That is really weird. We do not want to have like problems at runtime because these things were tightly coupled, and that's incorrect. And then there's also magic strings in your code base, which is also always kind of cause confusion. So these things we want to fix, because the power is that we can have iConfiguration, we can set it into classes and code, treat it as code, but we're now tightly coupling our configuration to our actual code, like to our business logic. And we don't want to be doing that. We're going to throw it away, and we're going to opt into the options pattern. So the options pattern has lots of different features. We're going to talk about a couple of them, right? So there's encapsulation, dependency injection, named options, validation, reload on change, post configuration, and just a whole lot more. So let's talk about options, and you'll see, and I'll explain why this is the preferred approach for using configuration in .NET in basically all cases. So we can use the options pattern in lots of different ways. This is the easiest one. So somewhere in your application startup or in your program.cs, we can say services.configure, and we're going to tell it, hey, configure the external API settings class again, and then you pass in your configuration system. And what it will now do, when you inject iOptions with the generic type somewhere in your class, and you call .value, because it's a lazy system, only when you call .value for the first time will it then go to your configuration system, and I'm like, I'm looking for external API settings. I found it. Let's now grab all of those properties. Let's map them to the class instance, and then pass that into this interface and give it to the user. So it's a lazy system, and it's a singleton as well. So the second time that this class gets instantiated, it no longer needs to go through the configuration system, because it will already have it cached in memory. And this basically fixes those problems that we talked about before. There's no more access to data that it doesn't need. It has no way to access database connection strings or feature flags or whatever it wants. This might seem tightly coupled to the configuration system, because we, in the previous slide, we said configure and passed in the configuration. But you can set up the option system in many different ways. Like we can also create option instances by calling configure and then doing API calls. So we're calling some API somewhere, getting that data back, putting that in the options, and the class will not know better. The class will see, hey, there's data. It does not actually know where it's coming from, so this is now loosely coupled from your configuration system. And of course, we also skipped out on having magic strings as well. So who is using options who's using options already? A lot of hands. That's great to see. It's good to see. So, validation, right? Just in general, right? Let's talk about validation here. Who here builds APIs? Who here thinks that validating input is a bad idea? Who is brave enough? No one. Okay, see? So everyone here agrees. Validating data user input is always a good idea. Who here validates their configuration system? Maybe 5, 6 people. So I want to kind of, I want to plant that little idea in your head. User input is always kind of scary. We want to validate it, SQL injections, etc. But configuration can be just as painful. Imagine a scenario where we are running on the test environment, but someone has set the database connection string to the prod database, and we're currently testing if deleting everything works. At that point, you've deleted your entire production database. Or if you've maybe set some discount to -1, and some really weird things start happening in your code. That is stuff that you also want to validate, and your application should not start up when it's configured incorrectly. And this is very easy to do with the options pattern, right? So there's an API URL, for example, the API key is back, the timeout in milliseconds, and now we can use these things called attributes you might be very familiar with if you've written ASP.NET Core applications before, where we can say the API URL is required, the API key is required, there's a timeout in milliseconds that needs to be between 1 and 100,000, or that's correct, a big number, I'm not sure, can't read. So, and how do you then actually start validating this? It's just 1 or 2 lines of code. Instead of saying .configure, we're now saying add options, and add options will return us an options builder, and this allows us to do a whole lot of powerful things. So, for instance, we're now saying bind configuration, and we're just passing in the name of external API settings, so we're now no longer needing to pass in the configuration system as well. It will just do this based on the dependency injection. And now we can call validate data annotations and validate on start. And this will then throw a validation right when your application starts up when your configuration system is incorrect. Now, of course, validating that your test environment is connected to your test database is not something you're going to do with attributes, but you can also call things like validate and pass in your own validation logic as well. And one thing that I want to give to you is that validate on start is extremely important. I already mentioned that the options pattern is actually lazy. So the first time you call .value on it, will it only actually execute the configuration, data grabbing, and also the validation in general. So you could write some code, and then half an hour later, it throws an exception, because at that point, only that code path was executed. Always add validate on start. Because only at that point, when the application will start up, it will actually like initialize all of these options and then crash, and your application can't even launch. That is what I always recommend people to do. I think since like .NET 7 or .NET 8, there's actually also a add options with validate on start method just to make this easier. Right. And then you also might want to keep it fresh. I already mentioned like reloading on change, or like changing configuration data without restarting your application, which is a very, very cool thing to do. Who here, when they want to change configuration, redeploys their application? A couple of hands, less than I expected, but that's really cool. Who needs to restart their application for configuration changes to get applied? Yeah, that's a lot more hands. Not really a big problem if you're also doing like blue-green stuff, where when you start or restart your application, it'll start a new instance, and only after that's done will it actually bring the old one down, so you have 0 downtime. But I don't see that all the time, right? So it would be really cool to be able to change configuration on the fly and then also have that reflected in our application code. No changes required, no redeploy, no restarts. So iOptions will not allow you to do that because it's a singleton and it read once. It cached the initial value. If you want this, you can use iOption snapshot. So this is a scoped service, and this will read every scope. The most popular example of a scope is, for example, an HTTP request in ASP.NET Core. So when we inject an iOption snapshot, like at the beginning of the request, I guess for you I should do it like here, I don't know, and we read configuration, during the request it might change, but even during the entire request we will always get the exact same value back because it is consistent for that entire scope. It's important. We don't want the database connection string to be something here and something else here during the request, because that's going to cause a lot of bad time. So it's very useful with web requests as well. You do need to keep performance in mind. Because this is going to read your configuration system every request, if you have a provider like in the cloud or something that's just very slow, it's going to slow down every request. So this is something that you do need to keep in mind and might need to monitor a little bit. There's also iOptions monitor. This is a singleton, right? So it's going to read your data in real time. The property here is also called current value instead of value. And this also allows you to say, like, you can also subscribe to changes with an on-change method. So every time the system changes, you get a little notification, so you can do some manual change tracking. This is very useful for background services, where the concept of a scope is not really a thing. Like, it's just a thing that runs forever. So these kind of interfaces are very important when you want to really treat your configuration as code and also support reload on change behavior. All right, let's deal with development. How do we prevent the Dutch tax administration mistake? How do we prevent the Mercedes-Benz mistake? How do we prevent the Rabbit R1 mistake and lots of other companies that store their secrets in their repo? Don't. Don't store them in your repo. It's very common to see companies doing this, especially when they have private repositories and it doesn't matter, it's secured, right? It doesn't matter, we can just store them in there. Stuff will leak at some point, right? That's a security thing. It's not if it'll go wrong, it's when will it go wrong. So make sure that you never store your secrets in your repositories. And how do you do that with .NET? There's multiple options, but the supported one, the one that you should use because it's the default one, is user secrets. Don't create like an app settings.local.json and add that to your gitignore, and then change your launch settings.json and change that to local. Don't add your app settings.development.json to your gitignore. Don't add it to the launch settings.json and add it to the gitignore. That's so much work for something that's already built in, right? That's the user secrets provider. We talked about it earlier. So what is this? This is another file provider, it's a JSON file, but it's actually stored outside of your repo. So any changes that you make in it are not included in the repo. That also means that whenever you clone the repo, you do not have data in there. So everyone in your team needs to reset the data. We're going to talk about Azure Key Vault later and maybe making that process easier. So how do you use this? Well, you can call .NET user secrets init if you want to do it in the terminal. It's also built into Visual Studio, Writer, Visual Studio Code. And now we can say user secrets set. So we can set the connection string to the data from the database to some data source. We can set the admin password like hunter2. And now we can see something like this will then be created on your disk outside of your repository. And this will be, depending on your OS, it will be stored somewhere else, right? So on Windows, it's stored in app data, Microsoft user secrets, secret ID, which is something that then will be set in your CS proj. It will be like some random GUID, and that is then, that is how it's connected, secrets.json. And then there's also, on Mac and on Linux, it's like in the .microsoft folder, and, then it's stored there. Be aware that they're not actually secret. Microsoft has a thing with naming, and this is another one of them. They're not secret. The user kind of secret, because they are just stored in plain text on your disk. Like there's no encryption happening with decryption when your application starts. They're just another file on your disk. If you have something on your computer that's reading those files, when you have bigger problems at that point, but do not consider this a full secure solution if you are working at a company that doesn't want secrets to be stored on the machine. Right? We're going to talk about that later as well. But they are just another provider. But this is then stored outside of the repo, and you can always prevent your secrets from being leaked into your Git commit history. Let's talk about a good setup for local development then. So of course, I should maybe put a warning there, opinions, right? I really like this approach. I'm curious what you think. And maybe we can talk about that later. But this is what I do in lots of companies, and lots of teams like this approach. .NET system, very flexible, very powerful. But the flexibility causes complexity, causes confusion, right? So if I need to know where the database connection string is coming from, and we're using like 6 different configuration providers, good luck. Good luck figuring out where to go, what to do. What if there's like 2 values? Which one is correct? You're going to have to try all of them out. So I like giving a little bit of structure into these files. Right? So in the app settings.json, I have like little placeholders, right? I create like database. Oh, that connection string comes from the Azure Key Vault. The admin password might come from the Azure Key Vault. The welcome text, that is just stored in the app settings.json. I don't mind. So that's just hello world. App settings.development.json. I like to make sure that to tell people, hey, you should use your user secrets here. This is the place to start learning about this. Because if you don't do this, people might still accidentally put the actual password in this file, commit it, and then you have problems again. Now I'm telling people, hey, you want to grab or insert a database connection string? Actually, you're supposed to do that in the user secrets. And we're also overriding the welcome text to hello developer, maybe. We can also do that as well. And then your user secrets, well, that's what I showed you in the last slide, right? Here we can say connection string to the database, admin password hunter2. And when you combine all of this, you've given the developer and your team and yourself a little bit of a handhold. Like, hey, these are the providers that we're using. If you want to know where something comes from, if you want to update something, this is a very nice approach. One thing that I'm kind of thinking about, like over the last few years, is maybe changing this to just like nulls or empty strings and then adding comments instead. Because now, the null empty string requirement, will just succeed because there's actually a string in there. So you could also just do everything in comments. It just doesn't look that nice. I don't know. Something you can think about. But something like this, telling people where it's coming from, is a good idea. I also considered putting it like in the README, but then no one updates that stuff. So then this is just gonna, get out of sync over time, and it'll just get worse. So I think putting this kind of stuff to where developers look makes sense. Right. One more thing I wanted to say here as well. So for like Docker and like Kubernetes world, it's also very common to just do everything in environment variables. In that case, I would still just say from env or something like that. Or maybe if the environment variables are stored in Azure Pipelines, maybe from Azure Pipelines env or whatever like that. Make it easy for yourself. Because I think we all spend a lot more time looking for like secret and configuration values than we actually think we do. All right. So it's time to push to production, right? We know configuration, we know the option system, we know to use user secrets, and now we need to go to production. Because the user secrets provider does not work in production, we need to look for different approaches. Right. So, what are some common approaches? I'm curious, when I explained this, let's do a little raise of hand and see who uses this or has seen this in the wild. So what I see quite often is that developers create like a little placeholder in their app settings.json with like a hashtag, curly brace, like connection string, and then curly brace hashtag, and then they replace this in their CI or CD pipeline. I hope you do it in your CD, because then you don't have to rebuild. And at that point, your secrets or configuration values are stored in Azure Pipelines or like as a secret. And then when you deploy, they are actually stored into that file, and that works. Who uses this approach? I see quite a few hands, kind of what I expected as well. So why I do not like this approach is because it goes against this default setup from .NET, where providers add like order and like add priority to each other. So instead of like overriding like a low-level provider like app.set-install.json or app.set-install-test.json where you want to insert secrets, why not consider like environment variables, right? You could in your deployment start using environment variables instead. So now you can also, do something like this, like during your deployment, is it like Docker or Kubernetes or whatever, and now you can set connection strings __ database is some value. So this value still needs to come from somewhere, right? And I also like this approach a little bit more, though this is like, it doesn't really matter, but it makes me feel better, I guess. It's because then environment variables to me feel a little bit more secure, maybe, than files. I'm not really sure about that yet, but it feels a little bit nicer because developers often also then just go to the test or production server and then copy that file to their disk, and that kind of just teaches them that is okay. And I just want to, make it a little bit more hard for developers to just steal secrets, I guess. I don't know. In any case, this works a lot better with what .NET wants you to do, to use another provider, or maybe even add your own provider instead of changing lower level ones. But then there's still the problem of where do we store those secret values, right? Now we've changed the way that we set them into our application, but they still need to come from somewhere. You can use Azure Pipelines variables, you can use GitHub Actions, secrets. It's all right, but it can be quite painful to manage those, right? So then there's the cloud. So I'm going to talk mainly about Azure now, but I want you to know that like AWS has their secret manager, Google has their secret manager. You can even use HashiCorp Vault if you want to do this on-premise, like if you are like a no-cloud club, that's fine. But this all works. And the cool thing about .NET's configuration system is that you can create your own providers, which all of these companies and all of these cloud providers, they have NuGet packages that add a configuration provider for their secret store. Right? So the Azure Key Vault, in this case, stores keys and secrets and certificates for you. And this can then be used as a configuration provider, and it simplifies your deployment so much. No longer in your CI/CD do you need to store them somewhere and then add them to your environment variables. And that's going to always be really annoying to do because you always need to change that stuff. You can just, when your application starts, it will go to the Azure cloud, grab the values, store them in the configuration system, and you're done. It'll just store them in memory, which is, I guess, also a little bit more secure. The Azure Key Vault also integrates with lots of other services like the Azure App Service and stuff. And this is also really useful during development. I talked about the user secrets being kind of secret because they are just still stored unencrypted on your disk. You could also say, well, maybe I don't want to store secrets at all. And then this is a really good approach for local development as well. Because now you can just clone a repo, press run, and then it will just run. Like it will immediately go to the cloud, grab those values, and you don't need to spend any time setting up these secrets locally on your machine, which is always really, really boring. And then there's also Azure App Configuration. Now, depending on how much time we have, I will do a demo for this in a few slides as well. We'll see how much time we have. But this is Azure Service for like configuration as a service. It's like your one-stop shop for managing your configuration just in one place. It has feature management, so you can like change feature flags, like A/B testing. You can change your features, your configuration values in the cloud without having to redeploy your applications. It integrates with the Azure Key Vault, right? So we can create in Azure App Configuration like a API key, and then we can say, grab the value from the Key Vault instead. So now your code only needs to have the add Azure App Configuration source, and no longer do we then need to mess around with lots of different providers. Right? We could sacrifice the flexibility of .NET configuration system and just use app configuration. We could also do both. I always like using the Azure App, like the Azure Key Vault, and then or Azure App Configuration, and then still overriding it with the user secrets again, because then I have the final choice. Like the Key Vault provides me the values for like by default talking to test, but if I want to talk to my local database, I put my local connection string in user secrets, and because that is then the final provider I added, that one will then win. It's different approaches you can use here. And it's super simple to get started with this, right? We just add a NuGet package, options, connect to app configuration, and boom. But then we do have a new problem. right? How can we securely connect to these services? It's great that we have a key vault, or app configuration, or AWS Secret Store, or Google, or whatever, but we need to pass in probably some kind of authentication, like a username and a password to talk to these things. If everyone would just be able to access my key vault, I've not really secured anything, because now it's just easier for my secrets to get stolen. So what do? Do we put a username and password in our app settings.json? No, because then we're committing them into the repo again, right? We just moved the problem somewhere else. And for Azure, that is where the Azure authentication stuff comes in, the Azure identity libraries, for example, right? So we already saw 2 slides ago the default Azure credential, and there's tons of these available to you, like the managed identity credential, Visual Studio credential, etc. And the default Azure credential is pretty good for local development, because what it will do is it'll take a look, like if you're using Visual Studio or VS Code, or if you're logged into Azure CLI or Azure PowerShell, it'll look for your Microsoft account credentials and then try to connect to your key vault. And most of the time, or basically always, that'll work, because hey, you're logged in with your Microsoft account is allowed to access the key vault, so then you don't even need to store any secrets to connect to the key vault at all. You can give me, or I can give all of you, my key vault URL. You can try to connect to it, it won't work, because I have not given you permission in the Azure cloud on your account to talk to my key vault. And if there's no secrets to manage, that's just the perfect world, right? But that is for development. So what happens when we're not running in development? Because I hope you guys are not installing like Visual Studio on your production servers, because you shouldn't be doing that. I add it on prod, by the way. It's the fastest deployment strategy. So for production, there's like in the default Azure credentials, there's multiple providers available. There's the environment variables that it'll try first, then there's the workload identity, and then there's the managed identity. Let me tell you first, I do not like using default Azure credential in production, because first of all, it's very slow, because it's going to loop through multiple methods. And maybe if you're using managed identity in production, and then someone sets the environment variables, it'll use that one, because that one is checked first. So then you might get really weird scenarios where suddenly your system stops working, because now it's authenticating differently. If you're using managed identity, just create a managed identity credential. It'll be a lot faster and a lot more clear about what you're doing. So let's talk about them. Yeah, I can have a whole session on managed identities and how they work, and they do exist. There's some really good resources online as well. So let's just kind of try to summarize what is happening here. So managed identities allow you to safely communicate with Azure without secrets. And this only works for services that are hosted in Azure, right? So we could have an app service, and that would have a managed identity, and then we can talk and we can tell the key vault or blob storage, this managed identity, so it's kind of like an Azure system user, is allowed to talk to you. And when your app service, which is then connected to this managed identity, performs a call to the cloud, to the key vault, it will recognize like, hey, I know that guy, and that guy is allowed to talk to me, and now you need to have 0 secrets to communicate between your services. This is, of course, not going to work when you're using something like SendGrid or some other external API like OpenAPI stuff. Of course, you still need the API keys for that, which you can then store in the key vault. But if you're connecting to another Azure service, managed identities are super, super powerful. Here's a concrete example, for the database, right? So normally, you should never show your database connection strings to anyone. There's always going to be some authentication details in there. But here, it's quite okay. Like, I still wouldn't really recommend it. I still store these things in the key vault, because what if someone does add a user ID and password to it? But as you can see, there's no user ID and password in there. The only thing that's in there is authentication equals Active Directory default. And this will then, in SQL, like in the Azure SQL driver things, will then again try connecting to all of these different providers. So again, you can't leak secrets when there aren't any secrets to leak. I see that we're doing great on time, at least for me. So let's have a look at a couple of demos. Let me switch to my code here. All right, if I blind you guys, let me know. Is this okay, or should I switch to dark theme? I see a fan of dark theme, but I saw more thumbs up, so we're going to keep it like this. I do agree. Dark theme is better, right? Okay, And also, is this big enough, or should I zoom in a little bit? It's good. Also, from all the way on the right, it's good. And the left, and everyone together. Okay, sorry. I have minutes to waste. So anyway, so what we're looking at here is a little application, an ASP.NET Core application that I've configured with like user secrets and the key vault. And what it allows us to do is there's two endpoints, right? And then we're going to get into the nitty-gritty details. There's two endpoints, /pizzas, where we're going to get a list of pizzas, and then there's an endpoint /connection string. You should always add this to production. It's really good. You should no, don't. So this endpoint will then return to me my database connection string, so I can show you guys what is happening. And what we're doing here is we're saying when the application starts up, if the environment is not development, then I want to add the add Azure Key Vault with this URL that's stored in my configuration system with the default Azure credential. Now, I talked a lot about also using the Key Vault during development. I've basically switched to always doing that because it just makes my developer experience so much easier. The onboarding in the team is so much better because someone can just clone and play. But you know, if you don't want that, if you don't want to pay a couple extra cents it costs, or if you do not want an internet dependency, this also works. But now, the secrets need to be coming from my user secrets. So you can use the CLI for this, like I showed you in the slides. But for example, in Visual Studio, if you right-click on a project, you can click on Manage User Secrets. And then this will, if it's not initialized, initialize it. And then it will load for you your JSON file. And like I said, this provider, and it doesn't want to work, there it is. This provider is not in my repo, right? So it is somewhere in app data. So any changes I make to this file and save, you can see there's no changes in my Git repository. So this is what you should be using by default if you're going to store secrets anywhere. So my app settings.json is telling me the key vault URI is kv, like secret storage.vault.azure.net. My app settings.development.json is telling me, hey, during development, I want you to store that thing in the user secrets instead. And then, yeah, that's basically it. So I can say when my EF core database contact gets initialized, the connection string, in this case, because it's just a single line of code, in creating options for all of this, to me is not really worth it. It's more about the business logic where I'm using options for. I'm telling it, get me the connection string, give me configuration, give me the connection string to the database, and connect. So here I'm running locally. Let me zoom in a bit further. And I'm going to execute the pizzas endpoint. And this will... What? This is the first time that this demo has not worked. The connection... Oh, wait, no, that makes sense. Because I have... Is this the problem? Yes, great, because I had incorrect stuff in my JSON file. Good. Okay, so here we can see like salami, Hawaii, margarita. Discussions on Hawaii being a real pizza, we can take that place after. But for now, you can see it is connecting to the database. It's using the user secrets to talk to a local SQL server. And the connection string is data source equals dot. And it's connecting to a local database. I've already deployed this in the best possible way to the Azure cloud by clicking right-click deploy in Visual Studio. And now we can have a look there as well. Give me a list of pizzas. It uses the same, and this is actually using an Azure SQL database. Give me the connection string. And here again, this is what I showed you in the slide earlier. There's authentication, Active Directory, default, right? So this connection string does not contain any secrets. Still, I store it in the key vault. I still think it's important to store these kind of strings in the key vault because you could say I'm just going to store it in the app settings.json in production, but if someone accidentally adds a secret to it because they're not really aware of how this stuff works in Azure, then you've immediately leaked the secret again. So storing these things, I still find them secret enough to treat them as such. Right, and I've been locked out of my entire portal. Please, don't let me log in. Right. How much time do I still have? 10 minutes. So, I'll quickly log in. Let me just quickly do an MFA. What are ways to sign in? Authenticator request. Just click approve. You don't need to check it. Number 53. Yes. Azure portal. Amazing. So here's a little example of how this is set up in Azure. I have in my repo, I have a little PowerShell script with like the AZ shell that deploys all of this, so you can kind of see exactly how it works. But here, when it's all deployed, we have an identity in our app service, and that is a system-assigned identity in this case that is enabled. And then we, for example, can configure our resource group, and then we can go to the actual key vault, and we can tell it, well, here's the secret to the database, and we can have like access policies and RBAC, and then tell it, hey, this application, the app service, is allowed to list and get your permissions. So now I have no need to manage any passwords, any usernames whatsoever. It's just done in cloud, in the Azure cloud. And I'm pretty sure that AWS has the same thing, and the Google Cloud probably has their own things as well. I can still quickly show you app configuration. So here I have Azure app configuration. This is optional. Like I don't always use this. It is quite costly a little bit, and it also depends if you're going to use the features. Like if you don't care about feature flags and like A/B testing and like changing things on reload, you might not need it. I think the Azure Key Vault is basically required for any secure project. This is a nice to have to me. Depends. The consultant answer is it depends, right? So here we have the connection string to the database, which is a key vault reference, and then I have like a hello, which is like a value of like maybe like world, and then in my code I can connect to this in the program.cs here by saying builder configuration add Azure app configuration, and we can connect to the app configuration that is stored in the app settings.json, because it's not a secret, it's just a URL. And then we tell, hey, if you want to talk to the key vault, please use this default Azure credential. And then maybe if you want to have Sentinel keys, which in short allow you to have one key, and when that value changes, your entire configuration setup will reload instead of it constantly checking every configuration value. So it's a bit more efficient. And now we can just have this as an extra configuration provider, and this will just work. All right, so here we have app configuration URL, and then it's set to the one in the cloud. And that's basically all there's to it. There's this deployed to Azure script that I mentioned earlier. It's going to create the database. It's going to create SQL Server. It's going to create an app service plan. And here it will create like a managed identity, and it'll tell the key vault, hey, let this managed identity get and list your secrets. And that's all there's to it. Okay, let me swap back. There we go. It's taking a while. Let's have a look. There we go. Okay, let me just quickly go back. I'm sorry for the flashing. There we go. Right, final two slides. Feel free to take your phone out and scan this QR code. It brings you right back to that blog post that I talked about earlier. There's some useful comments from people in the community as well that say like, hey, there's also this configuration key name, and it allows you to be even more flexible. It's really cool. So .NET's configuration system is powerful and very flexible. At its core, you can use iConfiguration with a set of providers to access your configuration. Use the options pattern to decouple your code from your configuration. This also allows you to use advanced features like validation and more. During local development, user secrets should be used to prevent leaking secrets into your code base. Store your secrets in the Azure Key Vault and retrieve them at runtime by using the related iConfiguration provider. Consider using this for local development too, together with Azure App Configuration. And finally, make use of Azure Managed Identities to connect Azure services together without needing any secrets at all. NDC Oslo, it's been so much fun to speak here today. It's kind of been a dream come true to be able to present for you. Before we leave and before we do all the questions and everything, let me just say that if you want a Dutch cookie called a stroopwafel, just come to me. There's lots of stickers that I always bring, so if you're interested in laptop stickers or maybe for your suitcase before you go home tonight, go and get some, and thank you for your time. All right. Any questions? And if it's too much or if you're on the back, just come to the front. I'll be here for like another hour before I have to go home.
Hello, NDC. Thank you, everybody, for being here on a Friday afternoon in the last presentation time slot of the entire conference. I appreciate it. Room full of people, that's very nice. We're here to talk about containers today. All right, I have a couple words about myself. I'm Oliver Sturm. People call me Ollie. I work for this company, DevExpress, where we make a lot of components and stuff like that. And we do use containers, but that's not related at all. So if you'd like to contact me at some point, find some details here. I never receive enough email, you see, so that's why I keep asking for it. So there it is. It's my own fault, really, isn't it? So this is what I have planned today, and we have a lot of stuff to walk through, basically. Well, I should say, perhaps, that the idea for this presentation was born when I realized that a lot of people have not really paid attention to containers for a long time, or maybe not enough, right? And now they find themselves in a situation where their teammates and their bosses and everybody else suddenly seems to think they know exactly how all that works, right? Like that. So it's a bit like when everybody suddenly thought you needed to know how to git cherry pick something or whatever, and you're like, well, I don't really, because I kind of wasn't thinking that was important. So the containers are a bit like that, I think. A lot of projects use them today. There's a lot of things you can do with them. And I'm hoping to pick all of you up somewhere where your current information status goes with regard to containers, and perhaps, give you a little more. So we'll see how that goes. Right, I'm going to just say a few more words. I've got like about 3 slides or so, I think, and the rest of everything I do will be live. I hope that works. I'm going to have some typing to do on here too, so that will be fun, but we'll manage, right? So that's the idea. So live demo is the biggest part. You have by now read the slide, I'm sure, so nothing much more to say about that, really. So what are containers, or rather, where do they come from? Where do they live, as it says on the slide? Well, containers originate from this Unix idea of what was called a change root jail. Anyone ever work with that? Yeah, I'm old, right? I am. There are a couple of hands, or like half hands, not bad. Yeah, so the idea was that basically you would have an encapsulation of some sort of a server process. That was the idea on Unix, at least at the time, right? If you're running a web server and it was supposed to be blocked off from the rest of the system, so that if somebody hacks the web server, they don't suddenly get access to everything else on the machine, right? Simple idea. And that idea sort of went from being a simple command, it was literally called change root in Unix, right? CH root, like that, to this entire plan of kernel-supported container environments that would have all their own allocated resources and all that kind of stuff. Now, if you think that sounds a lot like a virtual machine, it does, but the virtual machine works differently because it has, as you can see on that slide right there, a hypervisor, right? Some sort of a central coordination process that sort of takes care of all this, whereas the mechanism that brings containers onto a system, an operating system basically, does not require anything other than the host operating system to be able to sort of encapsulate those processes. So if you run containers on a Linux machine, for example, you can see that the processes running inside the containers appear side by side with those processes running on the host operating system, right? They are not visibly separate from the other processes, which, may be a pro or a con. You need to know what you're doing, of course, right, to make that work properly. But it does, okay? And then Microsoft came along and said, hey, we would like to do that too, but on Windows, we will need to use virtual machines to make it happen. And that's how containers ended up being run inside virtual machine environments on top of a hypervisor, basically, right? Which is also part of the diagram there. That's why it looks so funny with this orange bit sort of stretching around that way, right? So that's the story today, really. Microsoft has made some changes again with WSL coming along, so they can now integrate that better with the Linux environment and so on. So that's all cool, but we don't need to go into that in great detail. I just wanted to leave you with an impression. Where do containers belong, and what do they do, right? Where do they live in your system? So you can run them locally, you can run them on some sort of a remote system that you access through SSH or something, right? That's not a problem. You are familiar with the idea of deploying to containers, perhaps, right? In the cloud somewhere, where there are basically management interfaces for those purposes, running on machines that you never see, right? So that's all containers, basically. Today, we will talk a lot about the developer side of all that, and not so much the deployment and IT side of the same technology. So let's see. Oh, here we are. Yes, okay. So sometimes people ask me, where's all the colorful stuff that I can click on? I think it said that on the other slide as well, because that's literally a question I get sometimes. I will use Docker tools in this presentation to make things happen, right? You might have heard that there's also a thing called Podman that is an alternative UI, basically. So it'll lead us a bit too far to explain exactly how that works, but basically the container technology these days is integrated in most operating systems. So if you use Podman or Docker, you're not really using different container technology. You're using different front ends, different management libraries, and so on, and different user interfaces, slightly different ones, because they are all extremely basic. The user interface of Podman is the one in the background on the slide there. I appreciate you can't see everything that's there. It's not super important. There are just a few edit fields that you can fill some values in and click OK, and the thing just goes and runs a command line in the background for you, right? More or less like that. And in Docker, that doesn't even go quite that far. You mainly use the UI only to see what sorts of resources you have in your system, which images do you have downloaded, and so on. But a lot of the time, in the end, you do that from the command line. I have this here as well as a sort of joke right there. That is your UI, I'm afraid. Or I'm not afraid, really, not myself, but some people are. And the command line, of course, stretches from anything from your local development system, which in my case here is a Mac, but it could be a Windows machine running PowerShell, if you like, or running WSL. Anything you want, really. And of course, all the way to the deployment scenario I was talking about, where you might find yourself in an SSH session on some VPC in a cloud environment or something like that, right? So that's all the same thing, and that's why the command line is the primary user interface for everything that we'll do here today. Right, so let's see how things actually happen. Hang on just a sec, bit of water. So the first thing that I ever started doing with a Docker container is that I ran one, basically, right? That was my first exposure to this entire thing. Oh, I should ask, is the font here large enough for everybody in the back? Yes? Yes? All right, good, good. So I basically decided that I was going to use containers as a resource for my development purposes. So a client comes to me and says, hey, I need to be able to use MongoDB or something with my application system. I don't have MongoDB. Running it as a container is super simple to do, right? Running something in general works like this. You go Docker run like that. And it's always a great idea for your future reference to put --rm in there, which means remove. And that's interesting. Start by removing stuff, right? No, that means after the run is over, it will go and remove any artifacts that it has created in the local system so that nothing ends up hanging around. If you don't do that, you end up having lots of locally created volumes and stuff like that in your system after a while. So generally good idea. And the first image that people normally end up running is called Hello World. It actually says so during the installation of Docker itself, that you can use it to test whether Docker actually works properly on your system, right? So that's how we run things. And I said Mongo, so let's do Mongo, right? I'm just going to remove Hello World and put Mongo instead. And Mongo is quite verbose. It comes up and shows me a lot of things that are happening on startup of the MongoDB database server. So that doesn't entirely matter, but that's how easy we can start that, basically. Now, the containers that I create, terminology, first of all. The thing we run is called a container. the thing that it is created from is called an image, okay? So images are like the static thing that don't do anything. They are the templates that are used to generate containers, and they are then executed. And in order to execute the container, they need to know, of course, how that works. What is the actual command or so that needs to be run in this container? So at this point, obviously, the Mongo container went and ran the MongoDB database server, but I can also override this and say, give me a bash shell instead. And then absolutely nothing happens. That was on purpose, because that's something that people frequently do, right? They read somewhere, you can just put a command at the end and so on, which is totally true. But you also need to make sure with another parameter here, -it, they're technically two parameters, right? -I and -t, typical Unix thing that you can just combine them. This makes sure that the terminal environment actually binds itself to like the standard in and standard out file descriptors and stuff like that, so that we can interact with the container once it runs, which of course is necessary for bash, right? So now I'm inside the container, which has the interesting name of 3A7 something or other, and I'm the root user, typical Unix type command prompt right there. We can do like PS and see that there are practically no processes running inside this container right now. So I have successfully overridden the standard startup behavior of this container. It was supposed to be Mongo, and now it's just bash, right? Nothing else. You can see from the outside what the startup behavior of a container is by inspecting it. So we can do docker inspect Mongo, and it outputs a lot of stuff here that we can see. There are things here like the command item that says MongoDB. There is also, here it is, the entry point. That is a separate part of the startup process. Basically, both are used. The entry point and the command are combined. And the shell script that you see here with the entry point in this particular container is coded so that if I pass anything other than sort of Mongo there, it automatically just goes and executes it, which is why I was able to override the command for this container, which is just this bit here, just by putting bash, right? And I didn't do anything to override the docker entry point.sh part. I left it as it is. But that's specific to the container, okay? So the best way to figure this out is to read the container documentation, which of course exists on the website wherever you find that thing. I mean, in the case of Microsoft containers, they have their own documentation on Microsoft websites. Typically, you can find images like Mongo here, also in the Docker Hub, which is like a repository where these images come from and so on. So that varies. There is no secret trick to figuring it out necessarily, unless, of course, you're going to go in the container and read all the source code or something to find out what precisely it does, right? So in this case, the Mongo container is just coded that way that I can override it. I'll show you an example later with a .NET-based one where we have to override the entry point in order to do anything non-standard inside it. So we've managed to do this. Now let's see, what I'd really like to do just quickly is to do something useful inside this Mongo container as a quick example. So let's see, I'm going to run a Mongo again. Where are we? Like the normal one, here we go. Let's run this one. And now from a different terminal, I can do something like docker ps, and it tells me that this is now the running Docker container that I just started, right? It has a name, which is auto-generated over here. It's possible to assign your own one. It otherwise uses funny words to create one every time you run a container. It also has an ID, which I tend to use a lot more frequently than that. And this is the ID. That's actually just a short version. The real ID is like a lot longer. When you need to use the ID, we can actually refer to it by using any unique part of it, right? So in this case, F1 or something is going to do the trick. Now I can do docker exec and pass -it, okay, for the same reasons as before. And then I give the ID. So F1, this will use the existing container to execute another command in it. Let's go for bash one more time. And the difference now is that I can see the running Mongo process in there because I'm sort of getting into the container from the side, right? So I'm using the existing container to run my command. The reason we might want to do that is because with my running database server, I could bring up the Mongo shell here, like this, and do things with my database. db test insert one, curly event NDC location Oslo, like so, perhaps. Insert an actual data object in the database, right? We can interact with that running process just like that. And I'll leave it again and do another one like Mongo export, not expert, minus D, that's test, minus C, collection is also test. And we'll do quiet. And I think for better formatting, I should now remove this. Like so, and then maybe I pipe this into JQ and get a nicely formatted JSON output for like a backup or something you might imagine, right? From my running database server. So this is a very common thing that you use. And if you think about it from a developer's point of view, then of course you could also use this to prepare some kind of a database session, right? I can simply pipe information in and out of the container. I mean, I'm saying pipe because that's literally what I did right here. This is the pipe symbol that is sort of between the command that runs in the container and the other command that runs outside the container, right? The data is somehow finding its way from the inside to the outside at that point in time. That totally works, right? So this is a very common mechanism to actually be able to run backups from the outside of a container, simply attached to a database server, tell it to output all its information in some standardized format and save it to a file that is on the host machine and not inside the container anymore, right? So that's quite a common thing to do. So now perhaps you say, well, I'm not really excited about MongoDB because I never use it, which is why I decided to also show you a SQL Server example, okay? Anybody here SQL Server? Yeah? Probably. I thought so. So I've got this very simple example here, which is a bit of a .NET application that just goes and persists something. Actually, I think I've got this open here in Rider as well, so we can see, a bit of Entity Framework Core. We're just going to create a product, one of these ubiquitous rubber chickens that everybody needs these days, right? Very important thing, rubber chicken. And it just attempts to save this in a database. There is a connection string down here somewhere. Use SQL Server, it says, just find a SQL Server running locally, okay? But I don't have a SQL Server running locally. I don't want one really. I'm on a Mac. Maybe on the other hand, on a development system, maybe you already have a SQL Server running locally. What do you do then, right? So with the help of a Docker container, we can actually bring up such a server any old time we need it. And we can even, if we want to, run multiple ones in parallel in different containers using different network ports or something like that without any trouble. So that's a lot easier and also more flexible than the more old-fashioned approach of running some kind of installer and waiting an hour, right? I like that. So let's see what we can do. If I'm going to run this now, this is going to take us 15 seconds of our lives, I think, but obviously it will not be able to actually connect to anything, and it will give up after that. So meanwhile, in the other window here, we will go and run a SQL Server process. Now, we already know minus RM and minus IT. And what we need now, though, Microsoft being Microsoft for a start, we need some environment variables. And one of them is called accept EULA, right? So that's what my Microsoft comment is about. Very important thing, of course, for them. We need to accept the EULA every time we do anything. So that is an environment variable, the parameter being minus E down here, okay? And we also want to map, actually these are not exactly in order what I'm doing, never mind. We need to map a port, that's 1433. Everybody knows port 1433, right? It's the one that all the hackers go for when they try to get into your data, right? Very cool. So that's like the SQL Server thing. And this port is opened by the process that runs in the container. Docker automatically generates a sort of virtual network thing for that, if I don't tell it otherwise, right? You can do all sorts of things, but by default, it generates a virtual network that is separate from your own network. So the port 1433 is used by the process in the container, and with this syntax we have right there, I'm mapping it to port 1433 on my local host machine. As long as we just want, you know, what I'm doing right now, just quickly run one instance of SQL Server, that is exactly right. On the other hand, I could run several and just use a different local port mapping, of course, right? So that's possible in the same way. Okay, what else do we need? We need to set a password, so that's another environment variable, MS SQL SA password. And I actually need to make sure, that's what I've got notes for here, to do this exactly the same way that I did inside my test application, because the SQL Server container is actually very picky. If you use a password for your SA password that does not adhere to password guidelines that Microsoft defines, then the container is just simply not going to start, right? We saw with Mongo that that's not a problem somehow, but, you know, Microsoft, right? What can we do? So password should be correct, hopefully. And what else do we need? Oh, just as an example, I can also set a name here, like name SQL Server, right? That's a good name. Totally optional though, right? Just saying, because I mentioned it before. And then finally, what we need is the image name, just like before when I had like Hello World or Mongo. And for Microsoft SQL Server, the image name is mcr.microsoft.com/msql/server. And then follows something here. Well, not that, that's just shell completion. Follows something that I haven't talked about so far. And what follows after the colon is a tag. Now, the tag can basically be almost anything you want. Very often you find a tag that is just called latest, because that's like the latest version, presumably, right? But you can also use tags for versioning, and that's what Microsoft does. So we have a tag on the SQL Server that is called 2022, and then that has also got -latest on it. But this is completely up to the people who make those images, in this case, Microsoft, right? So you have to look up with them. Sometimes there are different tag versions where they use different underlying Linux versions. Sometimes they are different product versions. So there are actually SQL Server 2019 images available and that sort of thing, if you like. And there might be different sub-versions of that available. So in this case, I'm just going to go for latest. Now let's see if that works. It should just come up. Oh, okay, there it goes. It was waiting there for something for a moment. And, you know, it is just as verbose, of course, as the Mongo that we saw. Now, back in the other shell here, we can see the error that I did not exactly wait for that previously happened, right? It had an exception here because of the timeout, basically. I think this takes about 15 seconds. Oh, it ran for 17 seconds. That's creative, okay? Never mind, right? And if I run the same command again, now that SQL Server is available locally, it suddenly says, hey, we saved a product for this rubber chicken item. So that totally worked, right? So now I have a local SQL Server running, much the same as the Mongo one, and that's, like I said, that was how I began using Docker at some point, because I found that very valuable. If you work with different client projects, or you know, you'd like to simply quickly give something a try, whatever, locally to test something out while you have things installed on your machine. These days, I don't usually install products like SQL Server or so on my machine anymore. It's just not necessary. I just spin them up when I need them, right? SQL Server installation process, I think, I don't know, how long does that take today? Who did it recently? Oh, yeah, you did? Well, how long? 15 15 minutes, okay. You had a fast machine, right? I remember when that took almost 2 hours, but times change. I'm glad to hear it. Yeah, nevertheless, 15 minutes. Of course, the images that I'm using for these demos are already on my machine right now, so that's important to say. If they were not on my machine, that's why I haven't said anything about it specifically, the exact same commands that I was using would still work, because Docker would just say, okay, I need to go to an image registry, and it knows all the ones that I'm using here automatically, and find this image that I don't have. And then it goes and downloads it, right? So the only thing is you have to wait for it. That might take a little while. Some of those images, obviously, are gigabytes in size, depending what it is. So that's a bit of time going by, really, but nothing else. Okay, now a couple other things that we can do for running images before we get to the idea of also creating some for ourselves. I have, for example, an alias here configured in my system, which is called .NET 10, and it expands to a Docker command like this. Now, .NET 10 is currently in a preview state, right? I don't actually know what the current version number of the day is at the moment, doesn't matter. And I also do have it installed locally, to be fair, by now. But it is a great idea to use an image simply to be able to run an environment that you don't have installed locally, right? Because maybe you don't want to, and if you're afraid of breaking something else or whatever. With .NET on my machine, for some reason, that happens quite frequently when I try to have multiple major .NET versions with workloads and tools and stuff installed side by side. Suddenly I can't use my .NET command anymore. I have to reinstall everything. It has happened several times. I don't know if you're familiar with that problem. Anyway, by the by. Now, in this command here, we have two parameters that are kind of new. Here they are. So we've got this -v thing here, which is for volume. And it means that we are basically projecting, or the Unix terminology is mounting, a particular path into the running container. So the particular path is that, oops, what happened here? Is this, I can't use my arrow thing here anymore. Oh, there we go. There it is. The little dot, right, that's my path, because that is the local directory that I'm mounting into the container. And inside the container, it will use this path at /project, right? PRJ, whatever. Sometimes I call it source or something, it doesn't matter. It just means that the contents of the local folder that I'm currently in on the host machine will become available automatically inside the image, the container. And the -w here sets the working directory. So I'm also going to find myself in this particular path right away. So if I run this, we should see, let's do it. Here we go, that I can see the same contents. I'm zoomed in now, of this use-ef program, right? That is that I was just looking at on the outside of the container, but now I'm inside and I have a .NET 10 tool chain available. Actually, funny thing, if I do .NET version in here, it does show me that. Oh, that's fascinating. Maybe I'm in a different directory or something. Okay, I'm confused because I did have here a couple of, oh no, okay, I'm not confused anymore. Isn't that fantastic, like, when you feel that way? I was just remembering that I have a global JSON on this level of my repository right now because I was having some trouble with some of the Docker publish examples, .NET publish examples, I'll show you in a moment, when they were trying to use .NET 10, right? It's a preview, there are issues. So I brought that down to version 9 using this global JSON. And then now if I bring up my old version 10 command here again that I used a moment ago, and I do .NET ---- version like this, then there is all of a sudden an error. And that's what I was expecting, but I had forgotten that I was in the subdirectory. So when I did it the first time, the inside of the container could actually not see the global JSON that is one level higher up, right? So that structure had me confused there for a moment. So the container can see the folder. It's actually a pretty good illustration, the folder that we actually mount. But the fact that there is something else higher up in the hierarchy that would also be considered by .NET normally, right? We know that, but it doesn't work in this case because the container can't see it. Right, so anyway, this happens. If, on the other hand, I just go to some entirely different place, I'm still inside the container, right? I could totally go to a different directory where there's no collision there, and suddenly my .NET command, of course, returns the version 10 correctly, as you would expect. Okay, so that's kind of cool, working with these environments, that's good fun. I've also got an alias here, just as a quick side note, that looks like this. So I'm sort of combining another few different commands with the same thing. So I'm killing all my old object and bin folders first, if there are any, and then I'm running a build here just by passing the .NET build command right at the end, so I can quickly apply this to some kind of a local folder, right? So there are a lot of things like that you can do. Okay, now, oh yes, final example about running containers without creating them yourself. I have here a quick example for the project test containers. I don't know if you're familiar with that. It's kind of related to Docker because it uses Docker, but then again, you might never notice that if you don't really care. So for that reason, some people might be using test containers, I imagine, and never quite notice that they're actually based on the same technology we're talking about today. So in here, I've just got this simple class here, right, like this, that has test containers MS SQL thing here. And we create one of these MS SQL containers with MS SQL Builder, right? Stuff like that. So this is basically a library, new SQL connection that goes to the other container. This is a library that we can use in a testing setup. I think this is Microsoft Test, I think, MS Test that I'm using here, but doesn't matter, right? And this library enables you to spin up a container. In this case, again, I'm going for SQL Server, but I think they've got some 50 or so other types of infrastructure images that they can bind to directly. And then I'm running some code against this here, like a unit test, basically. And this executes with the running container. So let's get out of here and do .NET test. Oh, one thing before I start this, I've got this separate thing here. Oh, we've still got the SQL Server. Well, this is a command line tool that monitors Docker, right? It's called Lazy Docker. And it has now detected for me, because I totally forgot about that I've still got the SQL Server running on the other, in the other window here. Let's quit that one. Now the list is empty. Actually, let's quit out of it and rerun it so it's all empty. And this allows me to quickly trace. I'm going to flip back and forth. Once I do .NET test, I thought oh, hang on, what's going on? I'm in the wrong thing here now suddenly. How strange. .NET test, here's my command. And where's my, all right, oh, here's my lazy Docker. Okay, sorry about that. So, .NET test. Once I run this, I'm going to flip to the other window so we can see what happens. There it goes. Flip here, and we'll see that the container pops up that is automatically started. And now it started the SQL Server. You can see that run through. And after a few seconds, the process is over. Actually, I think it's over already. This one always hangs around another couple of seconds or so. Yeah, see? Build succeeded in 8 seconds. My container-based test has succeeded. And that's how easily you can use containers to run tests against whatever type infrastructure. And you can basically provide bootstrap data that it uses and all that kind of stuff for a database server, right? Like I said, they also have other types infrastructure available in this project that is all container-based and can be used the same way. So yeah, cool stuff, I thought. That was a quick demo really for something else you can you can utilize when you just run your own images. So, right. Now, for the purpose of actually creating images, that's my second part here, I thought I should mention quickly, hopefully, that .NET actually has built-in support to create Docker images, or generally container images these days. Some of you might have seen that. Microsoft has been pointing it out a couple of times at .NET Conf and whatever, but I don't know if it became a great big feature. Some people use it, I believe. It's very easy. So let's give it a try. I'm going to do .NET new console -o NDC 25 or something like that. And then go in there. That's the one, thank you. So .NET run, of course, is going to run that thing locally. Hello world, it says, lovely. Now, what we want to do is edit the project file here and put a couple of items in there that are necessary to make this particular project work with an image, with image publication, right? So I need to do is publishable, like that. Okay, thank you, Copilot. And we also need to do what's the name of that thing? Enable SDK container support, I think. Hey, okay, there we go. All right. So these two are required if you would like to use this mechanism I'll show you with a console application template, right? Microsoft being Microsoft, did I say that before? For other type project templates, for some reason, the mechanism is sometimes a bit different. So you're going to have to look that up, unfortunately. This is supported technically for all kinds of web API services and a variety of other template types, but the particular way that you make it work is not the same every time, right? Bit strange, but there it is. So let's save this, and then I can suddenly use the .NET publish command, right? You all know .NET publish, totally normal deployment thing, but we can use this. Let's make this quite verbose here, like this. And then we use a target that is suddenly available there, which is called publish, container, like so, and run. And it goes and builds a container, or an image really, which is a bit of a strange terminology that they apply there suddenly. It builds an image of my application, right? Fully automatically. This takes into account a lot of options that you might have or not have in your project file. Depending on your project's configuration, different build processes are used, and different base images are also used. So in this case, it decided to use a base image here called runtime, okay? There are several others. Microsoft has elaborate documentation. Again, I think there are probably about 12 or so at least different base images for various purposes. And they are usually auto-selected on the basis of the particular properties that you configure for your project. Of course, the Docker command itself has a lot of options, right? And Microsoft has gone to the effort of replicating many of these options in their own project file specification so that you can influence a lot of the same things by using .NET specific project options. So that's the idea there. Right, so if I do something like docker image ls pipe, grep NDC here, then we'll see this image. That's like a 319 megabyte image that has been created. This is a bit misleading, I should say, because basically in this image list that Docker outputs, you see it counts the size of the base images every time, right? Whereas the newly generated image really only occupies a small amount of data as much as the new image adds to the storage, basically. They use a layering mechanism, so your own new image might only use one extra layer, and there's only a small amount of data in there, maybe a few megabytes or so, but it will count all the megabytes of the underlying layers. And if I have 20 of those in the system, it'll count them 20 times, even though that's clearly quite untrue, right? So that's a little bit strange. So your image is not really entirely 319 MBs of size, but that's what Docker will show you here. Of course, we can also run it, like docker run -rm ndc 25, like so, and it says hello world, right? So that worked. Lovely. A couple of other things here. So for instance, let me show you this example quickly. We can build an alternative version of it by going -p, that's a project option. So we do publish trimmed equal true. That's an option you can use in a CS proj file as well, right? Not connected really to the whole thing. Container image tag, image tag equals trimmed. That is a special Docker publication option because it actually sets the tag to something other than latest, right? The previous one here was using latest. I didn't specifically mention that, but it did. So now we're going to use trimmed. And then finally, because I'm on a Mac ARM architecture, I need to tell it that the architecture of the target is supposed to be Linux ARM, because it will perform ahead of time compilation, and it needs to know that for that reason. So now we have a completely different image here, different project options, and we have a different base image called runtime depths, this time the one that is selected. And if we bring up this list again here, where did it go? Here it is. Then this image only has 105 megabytes of data there, so it's a lot smaller than the one we previously generated because it's trimmed and all sorts. There are ways of making it smaller still. Microsoft is now including all the globalization functionality in the standard base images. There are ways of setting certain project options that means that that goes away, and then you save a lot of memory again for the image. But yeah, these are optimizations you can apply. They will always have a certain size, these .NET images. .NET is not the smallest deployment size in the world, right? So nothing changes that. Okay, yeah, so these are a couple of variants in here. Oh, I was going to quickly show you that the interesting thing with these images is if I'm going to run, oh, actually, I haven't even run the trimmed one yet. Hey, there it goes, right? That works too. And if I do latest again, and then I do something like bash behind it, like we've seen, then you'll notice that they actually configure these images in such a way that they totally ignore any values behind the command line. They are passed to your running application as arguments, right? That's important to know. So if you were to accept some arguments in your main method, then you would be able to see those arguments that are being passed there. But I can't overload them like this. And instead, what I would have to do in this case is to do -- entry point bash. And that totally doesn't work either, does it? Because I think I forgot the -it in there. Okay, there we go, right? So now I'm in, okay? Now, the other funny thing, though, is, and this is a bit of a trick that's coming up here. Now, if I do the same with trimmed, you will find that that doesn't work either, because one of the things that is actually trimmed from the trimmed images is stuff like bash, right? There is no bash. It's a security feature, right? If there is no shell, then the bad hacker that might make their way into your running container can't so easily do anything with your system because there is no shell environment. However, Docker has a cool command which is called docker debug, and we can use that one. It basically runs a sort of sidecar container. And I've already got this on my system, otherwise it would go and download it. So now we're in this sidecar container and we're looking into the other image that doesn't have a bash shell. Now I have a bash shell and I'm in this path here inside this image, and I can look at it, and here's my compiled .NET application and all that kind of fun, right? I can even start it. They do this so cleverly that all the paths work and everything, so that's really nicely done, right? Nice little trick on the side, I think. Docker debug is not familiar to lots of people, I believe. Okay, now how much time do we have? 18 minutes. I've still got a lot of things to show you. Well, a few at least. Okay, so in order to build new Docker images, people sometimes use slightly strange approaches, right? For example, let me show you this here. I've just got an ordinary Rider project here. So this is the one that I was using here, the NDC 25 project. Now, if I'm going to add here a Docker file to this project, let's just go and do that, then you end up with this kind of thing. And you might have seen that before because that's a standard template, right? This is not specific to Rider or JetBrains or anything. Same thing is going to happen if you create a Docker file from the command line in your .NET Core project or whatever. So this thing is a case of where Microsoft came and said, hey, we like this Docker file thing. We're going to use that. We'll do it all completely differently, okay? So what they used is the multi-stage build process that is supported by Docker files. You can see this because we have multiple blocks and they each begin with this from statement. So we do something by way of using this runtime image, and then we do another thing here by way of using the SDK image, and then suddenly down here, we actually use the build alias that was generated up there to do another step on the basis of that, right? And so on. So that's all really cool. It'll take you a long time to understand all that and find your way through for complicated build systems, right? That's what that's for. Microsoft is using it for a totally different purpose, which is that in Visual Studio, they have some built-in magic mechanism that says, if we're running in the debugger, for example, then we will actually look at this Docker file and only execute the first, I think, 2 or 3 stages of it. Okay, that's what they do. They just randomly define that for themselves because it allows them basically to build an image that is sort of like a partial image up to the build step, but not the actual deploy step, right? So this one here, where it publishes this one, and then the last one here where it actually copies the build artifact into the final path and so on. So these steps are then randomly skipped by Visual Studio. Well, not randomly, of course, there's a plan, right? I'm just saying from the perspective of a Docker file, it's a random idea to say, we're just going to stop after 2 of them, right? For example, that's our idea of handling this. That's what they did, though, and that is why the standard Docker file that they generate always kind of looks this way. Now, if I was going to build an image on this basis, we can totally do that. Now I'm using the Docker command to build. So this goes Docker build, and we're going to assign a tag to it. So this will be NDC 25 manual build 1, right? And it needs the local directory, and it's going to find everything in there automatically and perform its build. Outputs a lot of things as well. And the end result of that is, let me find my last command here, there we go. The end result of that is that this new image that I just now built 7 seconds ago is exactly the same size, and it's also very similar internally, just to be clear, to the one that we built first, which is called latest, right? So that's basically the same thing, more or less, that they do there. Now, when I use Docker for local development, I don't usually use this kind of approach, to be fair. I just don't. It's not a useful approach in my eyes. What I do instead is something different. I'm going to rename this here and say this will be Dockerfile MS, Microsoft version, and we're just going to do a new one. And then we'll just start in there and say, from, so that's always where we begin with some sort of a base image, and that'll be microsoft.com/.NET SDK, right? We want to develop things, we use SDKs, and we do workdir/source, and we do copy, and copy everything from the local directory in there, and then we do .NET run, like that. And that's a good Docker file, right? I can read every bit of that. It's very simple, and it actually totally does its job. It's not quite perfect yet. We'll get there in a moment. But if I'm going to build this, that'll be my manual build number 2. Then, of course, one of the things we find is that it seems to be ginormously large, right? But that's, of course, because 1.24 gig or something like that is already the size of the standard SDK image. And that is, as I said, counted a second time against my image. Now, if I do this 10 more times, it looks like I've consumed, what is that, like 12 gigs of memory or something, but I haven't really. It's only there once, right? That's a bit of a lie by the Docker system. Anyway, so really large image. If I run this, it'll also kind of take a short while longer. Where did we have it last? Run. Okay, let's do this. So that will be manual test 2, manual build 2, not a test this time. So here we go. It takes just a second longer on startup because it actually builds my application first, right? But the advantage of that is that I can actually do inside that image whatever I want. So I can do .NET watch run, for example. And let's build this one more time and go for number 3. And then we do .NET run, manual build 3, and insert one of these volume mounting things here. So we were copying stuff into the source folder. So now I'm also mounting stuff into the source folder. And that means that the current version of the files I'm working with in my local file system are now available to the running process inside the container. So now here it says hello world, and if I go back to Rider and just go and change this and say hello NDC, then switch back, it is rebuilding right there and going hello NDC, right? Yes, we can do that locally too, but that's exactly my point, right? We can do that in a container too. And the container, of course, does not have to have the same environment that you're running locally, right? So this can totally watch whatever is going on. Hang on. Right. So we've seen these build processes. We have about 11 minutes. Yes, I can show you the coolest stuff. So what remains sort of to kind of bring everything full circle to where I started. And I said, look, you know, we have maybe some infrastructure like SQL Server or Mongo or whatever. So now we can also build systems that automatically run all the components we need in order to run our application system, even if that's like many processes, right? We're not going to do many processes, but we'll do one, plus the infrastructure we need, the SQL Server. So in my project here for the, I think it was called UseEF, okay? Let's just quickly quit this one. There we go. UseEF here, there is already a Docker file in here that kind of looks exactly like the one I just showed you. So I pre-created that secretly, right? Sneakily almost. And now I'm going to add another configuration file in here. And this file is called a Docker Compose file. Docker Compose, the file itself is called compose.yaml these days. Sometimes it used to be called docker-compose.yaml. If you see that somewhere, same thing, okay? They renamed that a little while ago. Now in here, we can now reference a variety of separate services. That's what they call it generally. Any individual running container is called a service in here. And one of them is already there, and it says, if the UseEF image doesn't exist yet, then we're just going to build it by using the Docker file that is in the local project. So that's what I was doing just before with my other project, right? Only now it would happen automatically. And then I can also go and add things in here. So I'm going to do SQL, and the image for it is, again, this weird and wonderful Microsoft thing, mcr.microsoft.com, MS SQL Server 2022 latest. That's what we were using, right? And I can do environment, like so, and put my MS SQL SA password in there. That, again, I must get right, otherwise we have login errors like that. And we'll do accept EULA 1, like so, right? So that's the same service that we previously ran manually, but now it's part of my config file. And what I can do now is, like, the real magic is the fact that I can connect the two. So up on this one, I'm going to go depends on and refer to the other one. What that does is it makes the service that is listed under SQL available inside the container for the UseEF application by the name SQL, right? Just like that. And so I'm going to go to my program CS and use this other variant of the connection string down here, which uses data source SQL as opposed to data source 127 and so on that was there before, right? The rest of it is the same. But this one now attempts to use the DNS name SQL, and that automatically resolves to the other running container. I mean, assuming we run it, which I haven't done yet, so let's go and do that. We do, oh, I'm in the wrong folder now. This would be UseEF, like this. And we do Docker Compose app, and I do -- build, which is technically not always required. It just makes sure that we're building the current version, right? Since I do this demo on my machine occasionally, I'm better off making sure that I actually build this right now. So let's do that. It quickly builds everything, and it runs SQL Server. And then at the end of it, more or less, I think, it should also be running the .NET application. Nothing happening at the moment, that's concerning. Sometimes it takes a second or three. Is it done already or what? I'm a bit confused. I don't know if it's already done. Sometimes it happens out of sequence. That is definitely possible. Let's see in the other window here if we have, yes, we have both of them running already, plus somehow another one that I forgot about in between apparently. Okay, that's all good. Process is running. Oh, look at that. It was in fact still doing something. That could have been related to the network connection, to be fair, because it did a .NET restore initially, right? And that might run very quickly a few times, and then the next time it might not have immediate contact to some online thing to do its checking and whatever. Maybe that's why it just took a while longer there. And it says product saved right here. Okay, so that's lovely. Now, I've got those two processes running just using the one configuration right there. And I'll also show you how to basically do the same thing we did before, where we combined them and we were able to also, let me tear this down, to also develop the code at the same time. In Docker Compose, we can add this configuration block in here. Hang on, like that. That is called develop. And there is a watch block, and we can make it watch things. This is actually a lot more elaborate and with lots more flexibility built in. Oops, that was not intentional. There we go. But, you know, the idea is the same. We're basically watching the local directory, and if anything changes there, we will make sure that the source folder inside the container is updated, synced, right, based on this little mode specifier there. And because we have .NET Watch running inside the container already, it should then rebuild the application. So let's give that a quick try and do up and build again and rerun this entire thing. There we go. Is it going to take so long again this time? I don't know. I was testing it a few times earlier and it ran more quickly than it does now. That's a bit boring. We do have a couple of runs coming up still. I noticed that I'm actually, oh, there it goes now. All right, okay. So Rubber Chicken was running, so let's make a quick change to that here. And go, you know, changed, save. And in the background, it should recognize that did I save this? I thought I did. It's not reacting, is it? That's totally my fault. I was going to point out to you that down here at the bottom of the window, you can see this thing called Enable Watch right there. Guess what you need to do with that in order to actually make watches work, right? Well, you have to execute it, unfortunately. So let's do that. Hit the W button. There's also the possibility of passing -W for watch to the command line right away. I did not do either of these things. So then, of course, it didn't work. So we're going to do change again, save. And this time it reacts and actually builds the thing. Lovely, okay? So now the last thing I want to show you, and that's hopefully going to be possible in the remaining few minutes that we have, is that this entire development that is now already looking reasonably convenient, I think, can get even better because we can even debug stuff that runs in containers. The mechanism to do this exactly depends a little bit on the tool you use. So in VS Code, for example, you should probably consider dev containers, which I have a quick slide about at the end. Really, we don't have enough time to look into that. I'm using Rider, and it doesn't need dev containers in there. It uses a built-in process, so that might vary a little depending what tools you use. But it's possible everywhere, basically. Let me quickly put a bit of code in here. Hello, while true, right? We're just going to keep doing something here indefinitely, like this, so that we can actually see, oh, hang on, I need like a thread.sleep or something in there. So we create one of these data records every 5 seconds, so we can see that, you know, working away, basically. And then build this one more time and run it. And now, of course, we expect that to start running and creating these records. I hope this is going to catch up with us in a second. Meanwhile, in Rider itself, I can now go, let me jump out of this mode here. I can now go to the Run menu and say Attach to Process, typical sort of debugger thing, right? And we can then attach to Docker right there and find the Docker that we're using, the particular image, the particular container, of course, in the list. And Rider has the ability to install a couple of remote execution tools into the image. That's where this differs, right? There isn't really some sort of a standard mechanism, but this is the way that they do it. Now I notice that the use EF one apparently is still not with us somehow. Is that possible? Yes, that is possible. I wonder why this does take quite so enormously long. Can that really be a network thing? Well, I was just realizing when I did it last time that I'm in a VPN here, so maybe if I kill that, let's give that one more quick try here. I hope that we can see this final example working quickly. I did that earlier several times and it came up quickly every time, so I'm confused. Maybe the Wi-Fi has lost its edge here somehow. Yeah, well, we might be running into technical trouble in the last couple of minutes of the talk here, apparently. I'm not really sure what I should do exactly to help resolve this. I suspect that it probably has something to do with some sort of online access that is not coming back to us as quickly as it should. So now we're waiting at the same spot again. I should probably modify this somehow so that we don't check anything online at this particular point here, but yeah. Well, I hope that in another minute or so we'll be able to see this happening. Oh, here we go. Oh, that was lucky. Okay. So, lovely. It should be able to talk to the database, presumably. Oh, yes, here we go. Okay, that was just in time. It says we have now got this rubber chicken and it saves the new one every 5 seconds. And the cool thing that I was just going to quickly show you is this, that if I'm going to go to Docker here again and reload this, there we go, that's my container. This process here goes pretty quickly. It also downloads some stuff online, but that's already on my machine. And here's now my container with the useEF process in it. And I can attach to this and simply run the debugger against this. The first thing that you see is that the running Rider instance actually shows me my console output from the separately running process inside the container, which is kind of cool, right? I think. It's like remote work, basically, right? And then we can also go and like put a breakpoint here somewhere and it stops and we can see the variables that are available in the context. So the product, for example, that we create right there with those rubber chicken details in it and everything, right? So yeah, that's really nice. And in this way, I personally work with environments that are contained inside containers all the time. I've just got a few more words to say here about development containers. I was mentioning that. I knew that we were never going to have enough time to actually look into that as well, so it's separate. It's the idea that you create a specification file, which is this dev-container.json thing up there, that tells you what a development environment looks like. Cool thing, right? So you can totally check that into source control and share it with other people. And it says, we need, you know, this SDK and those tools, and we also need, like, whatever, a bit of Python on the side to do something interesting with or whatever. And then you can use this tool chain from the development containers to spin up a container like that automatically. And this also integrates with environments like VS Code or Rider and so on, so it can happen fully automatically from that. So that's very cool. It uses containers. It basically uses a similar sort of remote development tool set that we just saw with this debugger that went into the running container. This is kind of similar, right? It uses a similar approach to work with the processes in the container. So cool stuff. Check that out. The rest of my slide deck here has a list of commands that I showed you. You don't have to take photos of those. I have here the QR code in the top right that gets you the entire slide deck. So check that out. There are some links to other things I mentioned in between. And that's me. I'm all done. I'll leave that up for you to photograph right there. Thank you very much for being here. I appreciate it. Cheers.